I'll poke through
We
the
can look
settings
at it
while I'm loading
together.
up. All right, we are live. For those of you that aren't participating, Stefano, if you wouldn't mind muting your mic, that'd be great.
Sure.
Also, Alex, for you as well. If you're gonna have background noise, you can either just mute yourself in Discord or mute your mic or whatever when you're not talking.
Yeah, I will. Don't worry.
Okay, perfect. Alrighty, welcome everybody to the C# YouTube tutorial series. I have some documentation pulled up here that I wrote up that's kind of going to outline what our goals are here. So on here I have 2 links here that we're going to kind of walk through. The goal here is to kind of, it's going to seem rudimentary and elementary. We're going to walk through the C# documentation together. I've taken kind of my own notes of how these things work and how I want to explain them, but we're still going to look at the documentation together because I think one of the places people struggle is when they're trying to read this documentation, either it just goes way over their head, or it's not. Sometimes it's just not the way they learn. So this is almost like a video tutorial of the Microsoft documentation, plus my perceptions of how the things that they portray should work. So the first 2 videos are just going to be language fundamentals. So in the first video, we're going to look through things like what even is C#, what is .NET, things like how variables are set, very, very basic stuff. So for those of you that are tuning in that have questions beyond that, that might be for the second stream. But if you still put questions either in the streaming discussion channel in the Discord or in the stream live chat on YouTube, I will see if I can't answer them in this video. If they do correspond better with the advanced language features, the next tutorial, I may push them off to that. Or, if everybody is staying in here and staying interactive, maybe we just knock it all out in one go. Okay, so my goal here is to kind of give you all the skills that are necessary to kind of be able to be a C# developer. And that's kind of a misleading term because you're not really a C# developer. You're usually a developer that happens to use C# for a platform, right? So you could use C# to make games, to make websites, to make mobile apps, or to make desktop applications that would run on Windows itself. So what we're gonna start out with is just making a console application because it's the most limited. There's not really any UI. It's more terminal based, and there's no like frameworks or libraries that are gonna get in our way and make things overly complicated. So once we make our first console app, we're gonna look at some web-based technologies, making HTTP requests, learning about how servers and clients work, and then after that, maybe we'll look at making our first web app, and then after that, depending on what you guys want. We'll look at making maybe some games in Unity or maybe some Windows desktop applications. Really, this once we get past the C# basics, the actual language itself, we can look at whatever frameworks or libraries that you guys want. It's kind of going to be led by the people that are watching the series. So let's go ahead and dive right into it. So I want to give you guys a rundown of C# and .NET. So C# as a language is, if you've ever done Java before, you'll find the syntax very familiar. They just added some I want to say they made it more modern, meaning that they made it more clean to write. There's not as much boilerplate code. There's not going to be a lot of things that get in your way. It's also open source. The platform itself, .NET, is open source. You can go look at the code. So what all can C# do? So C# can build cross-platform, meaning it can run on Windows, Linux, or Mac. It can also run on different types of architectures. So, for example, most machines would run on an x86, a 64-bit operating system. They can also run on ARM architectures, which would be for like specialized devices like maybe the HoloLens 2 or maybe a Raspberry Pi. And then, it can also be pushed up to the cloud and run on like a Linux machine. So there's a lot of places that it can be used, and you kind of have to figure out what you're interested in and what your use case is. For me personally, my use case is as a hobby. I like to develop games in Unity, and I also like to, at my work, at my day job, I do C# development, making a web application using ASP.NET. So the main terms you'll hear are ASP.NET, which is Microsoft's web application framework. You'll also hear about Xamarin, which is their mobile platform. It's cross-platform. We're not going to go over that unless somebody specifically requests it, because I personally don't think it's the best way to go. I've done a lot of iOS development with Zach, who's in the stream with us, and I personally think either native is the way to go. So you develop separate iOS and Android applications, or you'd use something more modern like Flutter. And then the last thing you'll hear about is Unity. Unity is a game development engine. So you probably, my bad. You've probably heard of Unreal Engine or Godot, other game engines. Unity is the one that integrates with the .NET framework. So I know when I first started doing .NET development, I was kind of confused. There wasn't really any good explanation. What does .NET even mean? So .NET is just Microsoft's umbrella term for working with their core set of languages, right? So you'll hear two different terms. You'll hear the .NET Core and the .NET Framework. C Sharp is a language that can be used inside of the .NET Framework, right? So .NET Core itself is a cross-platform implementation of the .NET Framework. So when the .NET Framework came out, I should look up my history. I don't know when it came out, 10 years ago or so. The .NET Framework was made to create applications for Windows, right? So applications that run on a Windows computer, right? They weren't meant to be, web applications or anything along those lines. So what they had to do is they had to take the .NET Framework and pull out the pieces that are common, similar to like I don't know, maybe reading from a file. Reading from a file on Windows is very different than reading from a file on Linux or Mac, right? So they had to basically pull out the components and the activities that you need to do and make them cross-platform, right? If you want to read from a file, the .NET Core would say, okay, you want to read from a file, we'll figure out what operating system you're on and we'll handle it for you. But .NET Framework would say, if you want to read from a file, you're going to have to do that on Windows, right? And then Xamarin and Mono. Xamarin is the mobile. Mono is what Unity uses. It's like a subset of the .NET Framework, right? And it's used to add extra functionality in or to have cross-platform use, right? So like Unity and Xamarin can both build to Android, iOS. I know Mono can build to Linux, Windows, Mac, etc. It can even build to like the Facebook gaming platform or whatever. It can build to Xbox, Switch, all that jazz. Um, so Mono really is a cross-platform implementation of the .NET framework, but it also has extra functionality tied into it that allows you to have access to like 3D math functionality and whatnot. We'll get into that way later. I'm trying to give you guys a in-depth overview of why these concepts exist and why you're going to keep hearing about them. Okay, so what else is included in the .NET Core, right? So we're gonna focus on .NET Core, not the framework, right? .NET Framework is just for Windows. We want to do .NET Core because we want to do cross-platform things, right? So what the other thing that's included in the .NET Core would be the CLR, or the Common Language Runtime. So basically what happens is, let's say we type in a program in C Sharp, F Sharp, or Visual Basic. What it'll do is it'll take the program that you've written and compile it down to bytecode, or basically it's something that can be executed, right? And it'll put it on this virtual machine or a process running on your computer that can run multiple different languages, right? So as long as your language can compile down to the way the runtime expects your language to operate, you could make your own language, and that would work on the .NET framework, right? So the three that Microsoft supports are C Sharp, F Sharp, and Visual Basic. Visual Basic was actually the first language I ever learned back in high school. It's super simple, it's type safe, and it's object oriented. If you don't know what type safe and object oriented means, we'll get into those more later. C Sharp is the more modern approach to Visual Basic. It's kind of its successor. It's also object oriented and type safe. F Sharp is their cross-platform language. Not that C Sharp isn't, but that's more of their focus on F Sharp. But it's also more of a functional-based language. So meaning, rather than typing up classes and whatnot, you're more looking to just have quick functions, more similar to Python or JavaScript. But there are still libraries and whatnot that allow you to do object-oriented and imperative programming. Some of the other things you'll hear about inside the .NET family is NuGet. And that's just the package manager, right? So if I say, I'm going to write a library that allows you to interact with console applications better or something like that, you'd be able to use NuGet to pull in those packages, and it would kind of manage. You'd say, I rely on this package in this class, and NuGet would kind of handle those things for you. The last thing you'll hear about is Visual Studio, and that's an IDE, or Integrated Development Environment. If I just flash Visual Studio for you, just so we don't stay too much in theory, Visual Studio is where you're going to be doing your programming. It'll help you run the applications. It'll be, what kind of lets you know that your programs are working and those type of things. But we'll get more in depth in that later. Okay, so now we're going to move on to the basics, the absolute fundamentals of C Sharp, and there's going to be a lot of things that have probably been covered before, but I'm going to cover them from my perspective and hopefully give you um, a second way of looking at things and maybe a more in-depth guide. At the same time, I want you guys to be able to ask questions as I'm talking, so that way, if somebody's glossed over something like how people have done math before, everybody knows how to do multiplication, division, I hope. But maybe somebody says, "Oh, I've tried to do math operations with an integer and a float, and it didn't work out how I expected." Ask those questions so that we can go into them in more depth that you don't get in other places. The reason we're doing this live is so that you can get these questions answered in the context that you're in, right? You don't want to go off and do other things and come back to this question later on when you could have learned it at the time and had a better understanding overall. Okay, so the type system. What is a type, right? When we're talking object-oriented programming, object-oriented really means we're talking about a classification of an object, right? So if you just look at any object in your room, right? Let's say I'm looking at a monitor right now. What would be the classification of a monitor? Its resolution, its color depth, its width and height. You know, its properties, but as well as the things that it can do. You know, it can display, it can update at 60 frames per second, those type of things, right? So when I'm talking about types, I'm talking about classifications of objects. And in C sharp, types are unified, meaning that every object that you create comes or inherits from object, meaning that when I create any class, and if you're coming from functional languages like JavaScript and Python, this won't make a terrible amount of sense until we get into the more object-oriented portion of this. So disclaimer: if this is going over your head, I'd highly recommend going back and watching this once we've gone through that. Um, but you kind of have to take incremental baby steps here. I want to give you guys things, give you the chance to digest them, and then maybe you come back and watch it later because it'll sink in deeper. Okay, so back to the unified type system. Having a unified type system is absolutely beautiful because if I have a class, let's call it animal, right? And animal automatically, no matter what you do, that class is going to inherit from object, right? So that gives me access to methods that object itself has. And if I just go, mm, I don't want to dive too deep into this because it is unnecessary, but I want to remember what the methods are. Okay, so these are the methods that come from object, right? So we can check whether one program is equal to another. We can get the hash code of it, meaning it's just a unique identifier to that specific reference in memory. We can get the type of that object. We can clone that object, and then we can also do a toString or print it out in some way that would make sense for you to read what data is inside of it, right? So these are the things that you inherit when you come from an object, right? Which is beautiful that you have access to these, because just about every class you're going to want to be able to know whether or not it's equal to another instance of itself, or be able to print it out, right? The other nice part about having a unified type system is that it's type safe, unlike JavaScript and Python. And you'll hear me kind of crap on JavaScript and Python because of this. And let's say I'm running some program and I run into an issue and I don't know, what the problem is. Well, I have to go into it and debug it and inspect what the issue is, right? And the nice part about having a type safe system is that I can go see what type of object this has, right? So if I have a type of dog, I can go see, okay, what's its number of legs? What's its length of hair? What color of hair is it? What breed is it, right? And if I'm in JavaScript and Python, those types aren't strictly defined. I don't have these are the four types of things that correspond to this classification of an object, right? Um, so those are the main overviews of the type system. We'll get way more in depth into this, but that is the overview that I want to give you. So now we're gonna actually start going into some code. I'm going to um, Hmm. I think we'll just push this over to the side. For those of you who don't know the hotkey that I just used, I am a very big hotkey person because it increases productivity. So I'm going to make sure you guys know these. If you hit the Windows key and any one of the arrows, so if I hit up, for example, to go up, if I hit down, it'll bring it down. If I hit Windows plus left, it'll bring it over to the left, and then it'll ask you which window you want to fill in with. So I want to keep this little guide that we have up, but I also want to have enough room for you guys to read. So we're going to get into basic arithmetic, or arithmetic. I don't know the enunciation on that. So C sharp. If you guys, were in preschool, or maybe not preschool, third grade. I don't know when you learn it. PEMDAS, PEMDEAS. Uh, it goes parentheses, exponents, multiplication, division, addition, subtraction. Right? It's the order of operations, right? And Alt up down. Elon Tusk. Alt up down. Oh. All right, that's a new one. I like that. If you have something highlighted and you hold Alt and use the up and down arrows, it'll take whatever you have highlighted and move it. That's kind of cool. Interesting. I love learning hotkeys. Thank you. Okay, so C Sharp will support the native or the order of operations that mathematicians have designed, right? So if I just say we have an integer called x, and it's equal to 0, right? If I do x equals 1 plus 2, well, from basic math, we should know this is 3. But if I do 1 plus 2 times 3, what should be executed first? 2 times 3, and then add 1, right? If we did it the other way, we'd get 3 times 3, which is 9. This way, the other way, we get 7, right? So it is, the order of operations is important for the output of a program, right? So we're going to get down to user input right here, but we're going to do output here real quick just so we can check these things. Since I jumped into this way too quick, I'm going to reopen this and show you guys how you get here. Alex, you still following along?
Yeah,
Muted.
I'm still here.
Okay, cool. I'm going to reopen this and we're going to live share you so you can hop in here and do these things with me. So we're going to open up a brand spanking new Visual Studio. You don't need to open it, Alex. I'll send you a link and it'll hop you into mine. So what you're going to do is you're going to open up Visual Studio. You're going to create a new project. And then you're going to find a .NET Core console app, and you can see the console app will work on it uses C#. It'll work on Linux, Mac, Windows, and it is a console app. I guess is the tag that they have. That's kind of unnecessary. So you'll hit next. You'll give it a name. You'll choose its location, and then you'll give it a name to the solution, which is kind of like a wrapper around the project. I'm not going to hit continue because this would create it. Since we already have one created, we can just go back one more, and you'll see here's where I have it saved, and I can click it, and it'll open up the solution. So that's how you would get to the point that I was previously. Sorry, I skipped over that. Okay, so one of the beautiful features about Visual Studio is this live share up here. Once you log into Microsoft Services, if you hit this live share button, it'll give you an invitation link that you can copy to your clipboard. I'm going to send it on over to Alex here, and when he clicks on that link, it will open up Visual Studio, and his Visual Studio will be synced to my Visual Studio. So if he types, it's kind of like a Google Doc, but for code, right? Alex, did you get that link?
Yep, got the link. I'm opening it up right now.
All right. And then over on the right-hand side here, let me close this guy. You'll see the once he opens up, this guy will kind of open up another window. You can see his email, which I probably should have hidden. But yeah, once he's in here, it should pop open another view called like participant view or something like that, and you'll be able to see who's in your session. Okay, so now you can see his cursor. So if you go ahead and type something, they'll be able to see it. Yep, cool. Alrighty. So what I want to do is we want to go through some just basic arithmetic examples. And this may seem somewhat rudimentary, but kind of just debugging these for yourselves and just seeing how they work can be super useful rather than just assuming you know how they work and then you have to use them later on in a bigger program and you didn't understand exactly how they work. Um, will kind of bite you in the butt. So Alex, what I want you to do here is in between each of these lines, print out the value of x because we want to see what the value is as we assign it. And while he's doing this, I'm going to go ahead and open up the C# guide. So you can see what Alex is doing here. He's doing console.writeLine, and he doesn't know the state of my program. I don't know if the errors synced up correctly, but if I hover over it, it says the name console does not exist in the current context, and I don't think he can add these for me. Well, I don't think he can do the show potential fixes. So if we just hover over any of the red lines, it'll tell you what the error is, and then if you hit show potential fixes, you'll see. Oh, it doesn't exist. What do we need? Using system. So this is importing the .NET Core system, right? And this allows the system itself has a library inside of it that has access to the console, right? And so now you'll see that we can, in fact, write out the console no longer has the red line, right? We know what that is. It turned green. We have access to that class. If I hover over it, you can see console comes from system, and then it gives you the description of what it is, right? It has access to the standard input and output for a console application. Now you can see WriteLine is freaking out. And the reason for that is if I were to get rid of this, and if I hit dot, it'll pop up with all the options, and I believe stars are like the most commonly used ones. If you hit like escape, it'll undo it. I just want to show this for people that want to build these in. If you hit control plus space at the same time, it'll pop back open this context menu. You can use the up and down arrows to select which one of the options you want, and when you hit tab, it'll autocomplete for you. And then when I open up one parenthesis, you'll see what the parameters for this function are. And then you can hit the up and down arrows. You can either click on them or use the up and down arrows, and you'll see all of the options, all of the overrides for this function. Right now, that's probably not going to make any sense, but we'll get to it later. I just want you to know how to use Visual Studio because a lot of these things they aren't explained anywhere. So you can see now he has access to this, and now if I put this x back that he was talking about and put a semicolon, we no longer have any errors. Um, a nice hotkey, some other hotkeys, if you hit Control X without anything selected, it'll delete the line. Control Z to undo, and then Control D as in dog to duplicate. So we just want to copy and paste these, so that way we initialize the value to x, so we print it. It should when we print this, it should be 0. Now we set x to 1 plus 2, so x should be 3. And then now we do this guy, so it should be 2 times 3, which is 6, plus 1, so it should print out 7. If we go up to here and hit start, or you could also hit F5, it'll start, it'll give you an output down here of what's going on in your application, and then it'll run. And if you don't, if I just do console.read, um, so basically what's going to happen, right? I probably should have explained this a little bit better. So we're wrapped in a class, right? And then we're in this main function. And the main function, this is where a console application would start. So the first line inside of a main function is the first one that's executed. Well, this guy is a comment, right? So he's not going to be executed. This guy's a comment. He's not going to be executed. So this is going to be the first line that's executed. Well, if we do this guy, if we just keep going, before I put this read in here, it would have just gone through these guys and exited the application, right? Because there's nothing to keep it open. But if I put in a console.read, which is like trying to say, hey, like send me some input so I can read it. If I don't put anything similar to this that keeps the console open, it'll just close itself, right? Something that you guys may not have noticed, these yellow and green bars on the left-hand side. Yellow means it's something that is unsaved, green means it's saved. So if I just hit enter, you'll see a new yellow line. If I hit Control S to save, it turns green. All right, so if I go ahead and hit start, you can see the console application opens up here. If I hit Control and plus, Control Shift plus, all right, console does not have the normal font sizes. Properties. Sorry, I'm trying to blow it up for you guys. 24. Okay, so now you can see the values you printed out were 0, 3, and 7, right? Because all we did was we initialized the variable to 0 and we printed it out, right? Okay, so now we can get more complicated with it, and just like regular mathematics, let's go ahead and stop our application. If we put parentheses on this side, it would be 1 plus 2 and then times 3, so it should print out 9. And 9 we get. Okay, so then we can play around with division and whatnot. These are concepts that you should learn on your own. They should be relatively simple to find examples of. However, if you don't find examples of these very, very core concepts, Zach and I are going to be making a computer science fundamentals course later on that will go over like data structures, algorithms, mathematics that you'll need to know, those type of things. How floats and booleans and those type of things work. We don't want to do that in this because we're just trying to teach you guys C#. We're not trying to teach you things that would be common to multiple languages, right? And in a lot of languages, the order of operations is what's the word I'm looking for? Supported. So the next thing that I want to show you is that there is a math library built into C#, so I could do math dot, and you can see we can get the max of two numbers, the minimum of two numbers. We have access to pi, square root, all the normal functions, trig and basic algebra that you need to do. If you wanted to do so, um, you can just use these like any function, right? So if I do pow, which stands for power, if we do 2 to the power of 2, knowing what these are is kind of hard without some previous experience. So what you'll want to do is read the little tooltips that it gives you. So it says we're going to return a number raised to the specified power. So we're going to take 2 to the power of 2. And it's going to return something, so we have to set it equal to something. So we can just set x equal to that. And if we run it again, you can see the return type here is a double, but our x is an int. So what we're going to do, we're going to gloss over this for now, but basically we're saying, hey, Mr. Double, I want you to be an integer, which just rounds it down. Oh, we didn't do another right line, my bad. It should print out 4. There we go. Okay. So, does anybody have any questions on the mathematics as we're going through them? I feel like we took some very, very rudimentary examples. Does somebody want to go through a more complex example of how we would do things? Any questions here? I don't want to move on before I give you a chance to speak. No. All right.
Hello?
Yeah. What's up?
Oh, no, no, just go ahead. I'm a bit behind on the YouTube because it was lagging, but no, go for it. It's all good.
Elon Tusk. What do you mean by the seed? For random is auto-defined. Okay, so Elon Tusk in the stream chat is asking about random. So if you do math dot random, yeah, okay, so random is another class that comes
In
in.
some language,
Go ahead.
in some languages, you have to set it yourself, right?
Yeah, so random, it is very hard to be truly random, right? Because if I say one of the most common ways that people thought to be random was to basically say we're going to do a random number and let's just take some prime number times our current time in milliseconds. Um, so most times are done in like however many milliseconds it's been since January 1st, 1970. Don't ask me why that's a thing. It's called epoch, EPOCH, if you want to look it up. So that was how random was previously thought to be. Was let's take some random prime number and multiply it by whatever our time in milliseconds is. So every time we call random, it will be different, right? Because we're at a different time. Even if we're a millisecond away, our random number will be different. But that's not truly random, right? We have a precondition saying what random is. So what Elon Tusk was saying is we can provide a seed or a um, baseline for what random should be. So if we do random, if I'm being 100% honest, I haven't used random in C Sharp. I've only used it in Unity. So let's do it a
Well, I was
develop.
gonna say,
Go ahead.
for somebody beginning just watching this for C sharp that have had no experience, I would say if you're gonna do the random and the seed stuff, I would just do it in a new project,
In a
just so
new
they don't get
project.
overwhelmed by all of it. Yeah.
That's fair. Hold on. We'll do this. We don't need any of that anymore.
Okay, that works.
I've never used random before, so we're gonna look it up together. Okay, so you create a new random. Alrighty. So we got var is another way. So you'll see var is really common in dynamically typed languages like Python and JavaScript. Var just means, hold on, if I go my random number is equal to a new random. And if we hover over my random number now, you'll see its type is actually random. Var basically means whatever you put on the right-hand side, since we are a uniformly typed language, we know what type we are when we say var. We just don't, you just, like, normally you just say our type over here is random, right? But if you put var, you can make it a little bit cleaner, saying we know we're a variable, we don't need to put our type here. That's just kind of unnecessary. Um, var is also common in other modern languages and is becoming increasingly popular. It's commonly seen in Swift, in Kotlin. In Swift, for example, it would be var for all changeable variables and let for all constant variables. Um, so we can keep it baseline. I just wanted to, these guys are doing var, so I just wanted to explain that so that way nobody's confused. So now that we have access to a random, if I just start typing something, right, you can see how it'll find my variable. I don't have to type it in the right order, right? And now I can do dot, and we can say we want to get the next random number with whatever seed we're using, I assume. And we want to give it a minimum value and a maximum value, and those are integers, right? So let's get a random number between 0 and 100. And then we'll just print it out. Actually, this returns an integer. So we need to say the random one. And we need to print out that random number. And then we could keep doing this, right? We could say random 2 and random 3. And now we could just print out random 1, random 2, and random 3. And if we run, oh, I got 2 commas. Fine. If you when you do a write line, it wants you to have a string, right? Not an integer, because we have an integer. So I have to do a toString to turn it into a string, which will just basically print out what that number is. So I thought it was going to handle it for me. Actually, I believe if I cheat here, check this out. I don't need this. Haha. Okay, I'm a cheater. So this is basically saying we're gonna have an empty string, so basically no characters. And as soon as we have one string in here, C# goes, oh, okay, we know the type of whatever's in here should be a string, so it will inherently call toString on each of these variables for us, rather than us having to manually call it. So if we go ahead and run it, we don't have a read, so it just instantly ends. Okay, I didn't put a space in between them, so they're all jumbled up. So if we put, I gotta end the program. What's the hotkey for that? Shift F5. That my hands are never gonna remember that. So this may look a little funky to you while we're on it. This is called string concatenation. So basically what this is saying is if random, let's say this guy is equal to 1, this guy is equal to 2, and this guy is equal to 3. Basically what this is saying is what we want to print out is 1, 2, 3 with a space in between them, right? So if we got rid of this space, all it would do is it'd say we want to take this string and smush them together, right? So it would be 1, 2, right? But we want spaces in between them so we know how to differentiate them. So if we hit F5, you'll see we get 3 random numbers between 0 and 100. We get 72, 94, and 37, all with a space in between them. Okay, that was a really long roundabout way for saying, is random auto-defined? Yes, random is automatically defined. I don't know if we can put a seed into it. Let's go check. Oh, that's the integer. We want to do... I don't see a method for being able to check the seed, but you can put in a different minimum and maximum value if you want something outside of the bounds of what you were asking for previously. So it may... I just want to clear something up about how development works real quick. It may seem like, oh, this guy doesn't know how to set a random seed. I know that seems somewhat trivial of a topic to bring up. But a lot of the things that you're going to learn as you're programming is that you only need to learn things as you need to learn them. So for example, in Unity, I have a library called random in Unity that works completely different from how the one built into C# works, right? So I just haven't used it. But as you start learning how these libraries work and where to look for how their functionality exists, you'll see that as we're on stream, I will look these things up with you so you can see my thought process as to how I'm looking into them, right? I'm not gonna sit here and pretend that I know how everything in C# works. This is gonna be a learning experience for me too. I've been doing it for quite a few years, so I know a decent amount of it. But this is going to make me better as a developer as well. So I want everybody to keep that in mind that I'm no C# god.
Well, and I'll kind of tack on to that. So I got in contact with Sabian, last week. What would you say,
Oh my
like
goodness, I should have
Tuesday,
introduced you.
Wednesday?
I'm so sorry.
No, you're fine. No, you're good. Before we do that, I just started doing C#, practicing C# on Monday. I've literally just learned the basics. I didn't need to learn how to do inputs or anything until Sabian. I kind of talked to you about this last night. Uh, looking through multiple lines, if you have to tweak something, say, character, age, so int, any kind of variable that you would need in your code. I didn't need up until that point to learn, how to put an input into my code. So again, like Sabian just said, have to go in and relearn it. I don't think anybody has the mental space to remember every single thing that C# has to offer as far as a programming language.
Yeah, you're 100% right. And like Elon Tusk said, I know you're in the Discord. I'm sorry, I don't remember your Discord name. But like he said, Googling is an art form, right?
For sure.
I wouldn't necessarily go so far to say it's an art form so much as a talent that you can acquire, right? Like just knowing for example, if I just typed in random into Google, it may come up with any number of things, but I put the word C# and random, maybe I'll get closer. And then like as you're getting more used to where the documentation is for a language, you'll see that, for C# more often than not, it comes from docs.microsoft.com, right? So that's how you know it's like a good source. And you kind of have to learn these things by trial and error or asking someone who happens to have been in the space for a little while. Um, so you'll see that, I don't want anybody to be discouraged by this because you're going to hit roadblocks every single day, no matter what. Even if you're trying to do the simplest of things, maybe you hit some random bug and you forgot to put a semicolon or something and you're just not figuring it out. So yeah, get used to Googling, get used to hitting roadblocks. It's gonna happen every day. It's such a satisfying feeling to be stuck on a bug for a day and then figure it out right at the last moment. Be like, oh, finally, I'm a god. I figured it out. Nobody else would have figured that out. I'm awesome. Wait, just kidding. That was an easy bug. Everybody else would have done. But I know for next time. um, okay, so I feel like I've gone over a lot. I want to go back and I should have written out an introduction. So in the stream chat, or in the Discord channel, for those that aren't in the Discord, we have a streaming voice channel. Feel free to hop in here and ask questions over voice rather than talking to the asking them in the stream chat. Um, with me, I have Zach, or Zero X Leaf. He's one of the community managers of OneLeaf. He's not a C# specialist, but he's really good at programming languages. He's one of the community managers, and he specializes in Swift and iOS. Go check out his Swift series that he's starting. He's doing something very, very similar to me, but with Swift. The other person I have in the chat with me is Alex. He's a very brand new beginner into programming. The reason we have him here is he's kind of our guinea pig. I want to have a beginner on the stream with us that can basically say, can you slow down? I'm not quite sure what you mean by this, because even if for some reason nobody happened to see my Reddit post or the post in Discord, I would have Alex here to ask those beginner level questions. The last person that's in the Discord with us is Stefano. I actually just met him today. He's just here tagging along for the ride and being able to ask questions. Anybody else can feel free to hop in the Discord and ask questions as well. Oh, Smug. He said you can put a seed in the constructor. So if we go to random and we open this up and we hit the down arrow, you see, okay, so the first iteration of random is just an empty. If we hit the down arrow, you can see we're at 2 of 2 and you can put in a seed. So we could just put in, something random. And this says it initializes a new instance of class using a different seed value. So basically this is you could actually, it has a better explanation than I could offer at the bottom. A seed is a number used to calculate a starting value for a pseudo-random number sequence. Pseudo meaning somewhat random, right? It's perceived to be as random from the naked eye, but it's not truly random because we know how the algorithm works. So we would know what the output would be given, whatever the input is. So you can see if I go ahead and put a normal integer. I put too big of an integer in here, right? It says we want an integer 32, which is a 32-bit integer. 32. I'm going to leave that for another video. That is a separate topic. But if I put too long of an integer in here, it doesn't know how to display that because there's not enough memory to support an integer 32. Anyways, thanks for that comment, Smug. That was beautiful. Back to our guide here. Okay, so we did a little bit of basic arithmetic. Any other questions as we went through that? I feel like I went through it quick. Do we need to talk about how things are instantiated? Does this syntax even make sense to you guys?
If you need to follow along, I've literally, with random, since it's such a new thing, I literally have Stack Overflow on my iPad right now. So definitely
Nice.
Stack Overflow and Google is your best friend with all of this.
I'll go ahead and reiterate here just what this does. We create an instance of the random class. And what the random class has, it has a seed saying this is our starting point for how we're going to calculate the random number. And then we say using that seed, get the next random number that our algorithm generates between 0 and 100. And then we do that 3 times. And then we print that out. And then we have this read line to make sure our program doesn't stop. Does that make absolutely clear sense, Alex?
Yeah, I'm following along.
Okay, perfect. I'm just making sure.
Very
Stefano, does
good.
that make sense to you? I know you're even more brand new to C#.
Hey, yeah, no, I'm just happy to be here. To be honest, I'm kind of struggling a little bit, but I think that's also because my the channel, the YouTube thing is slowing down. But I'll go back and watch it, like no problem.
Okay.
But just keep going, and I'm keeping up.
Okay. So we will revisit random in the future maybe, because it might not make sense because you don't know how functions and classes work.
Well,
Go ahead.
try giving the integers actual names as well as doing each line with different integers. So like I know you have all of them as 0 to 100. Try doing like in between different integers just to see how it prints out in the console.
So our
See if
first
that
one will
helps.
make it between 100 and 1,000. Our second one will do between 0 and 10, and our third one will do between 10 and 100, right? So we know they
Right.
can't overlap, right?
Right.
And we'll give them new numbers. We'll give them new names. Actually, fun fact in Visual Studio. if I copy this random 1 back up, right? This guy's freaking out because it doesn't know that this variable exists, right? If I were to delete this line, the compiler says, you didn't instantiate anything named random1. It doesn't exist. What are you talking about? If we put it back, it'll quit freaking out. But something really cool that you can do is if you left click on it, you can see that it highlights this random1 where it's created, right? This is how it's created. And then here's where it's referenced, right? So you can see it highlights that for you. If I click on random2, it'll highlight where it's referenced, and same with random3. So if we want to change the name of something, I don't want to change this name and then copy and paste it down. I want to right click on this guy. I want to go to refactor. Where's refactor? I know the hotkey. I don't know where to find it. Oh, rename, dude. So you have to. I don't know why Visual Studio's hotkeys are so bad. You can change these on your own. But if you want to rename something, you have to hit Control R twice, right? Or you can just click this button, and you'll see it highlights it, and it gives us this guy up here. But if we just start typing, and we'll say it first random number is what we want this to be called. You'll see down below, it's editing that guy too. And when I hit enter, it updates both of them, right? So if we want to rename something, we don't want to go copy that and make sure we remember where everything's stored. We just want to update one and have it rename everything else. So we have our second random number. And then just to show you that the variable names really don't matter here, it's just where they're referenced, we'll leave the third one different. And then when we run, the first value that's printed is between 100 and 1000, 588. The second value is between 0 and 10, it's 0. And the third value is between 10 and 100, 17. I feel like we kind of went down a path that was a little more complicated for beginners, so we'll go ahead and back it back up and go back to the very basics here. So we're just gonna understand the syntax of C#. We'll get to user input and everything else later, but I want you guys to truly understand the syntax. So we have a few different types of statements. Statements being types of lines that we can make. The first type of statement is I'm going to put it in a comment so that way it doesn't give us red lines and not let us run. It's going to be type name, and then our second statement will be type name equals value. So to give you an example, we will say integer x. We have our type, which is integer, and we have the name of the variable x. We can do integer y is equal to 1. We have the type of our variable, which is integer. We have the name of our variable, which is y, and the value of y is 1. So what this is doing at the very highest level is when we do integer x, x currently isn't equal to anything. Since it's an integer, this is kind of an off case. If I were to make this some other data type that's not a primitive, like integer, float, boolean, we'll go over those in just a second. It would be equal to null. And so if I were to say equals null here, it'll freak out because null is not allowed on the integer type, but I believe string is. So we'll go down here and give you another example. We'll just call it my string is equal to null. So what null means is that this guy does not hold a value, right? So when we hit the start button, what happens? It creates a stack of functions, right? So we enter into our code through here, right? We know we're in the main method. And then it starts executing each line, right? If it has the 2 slashes, it's a comment. We don't execute this line, right? The first line we're going to execute in our program is this one. So what this does is it says, we want to create a variable. And we want to create that in memory, right? And so what do we need to put in memory? Well, we need to put an integer. Well, how does an integer look in memory? Well, it's a 32-bit signed integer. What that basically means is in memory, in our process, we're going to have 32 bits referencing this integer. So you're going to have, 0, 0, 0, 0, 0, 32 of those, and then instead of zeros, they'd be ones and zeros of a bit according to that number, right? So if we use a different type, like float, which is a floating point value, it just means it's a decimal value, right? It's integer is whole numbers, a float is a decimal. So you can see this one doesn't tell us the precision. I believe it's 64 bits instead, right? So as we create these things, the process says I am allowed to use this set of memory, right? If I love doing this. I open up Paint to give you a visual drawing. Okay, so this big square is all of the memory that our computer has, right? And we're talking about RAM, right? We're talking about the memory that your processes can access without having to reach into your hard drive. So your RAM is chunked up into a bunch of different processes, right? And it's storing what things are currently going on. For example, if I just go into my task manager and I look at performance, you can see my memory, which is my RAM, what its usage is, right? I have 16 gigabytes of it, and right now we're using 6.6 gigabytes of it. So if I were to start a program, my program would say, okay, you're allowed to use this much RAM, right? Let's just say it's, I don't know, 100 megabytes. In that RAM, what should we store? Oh, we need to store a float, and we need to store an integer, and we need to store a string. Well, our float isn't assigned to anything. It could be all zeros as bits, or it could be all ones. It doesn't matter. It's just a null value, right? Null meaning it doesn't have a value. An integer, for example, can't have a null value, right? That doesn't make sense. In mathematics, a number can't be nothing. The closest we can get to that is 0, but 0 is still a value, right? That is represented in bit form by just 0, 0, 0, 0, 0, so on, right? I lost my train of thought. Okay, so when we use the equal sign, we're saying this thing that we're referencing in memory, right? A y is a value that's somewhere inside of this box of memory. We don't know where it's at, right? It could be, we could chunk it off. So like the first set is here, and so like this could be variable x and this could be variable y. The operating system handled this stuff for you. You don't have to know about this. I'm just trying to give you an idea of what's going on under the hood, right? So we have our variable x, and it's just it's this black box full of we don't know what because it's null, and then y. We know this chunk of memory has the value of 1. And then my string is also null. We can't set floats or ints to be null, I don't think. Yeah, because um, it's not a nullable type, meaning that it has to have some value. And we talked about this with the integer meaning. Like an integer has to have some value. It can be from negative infinity to infinity depending on the amount of memory that we have, right? But it has to have some value. An integer, it doesn't conceptually or logically make sense that it doesn't have to have a value. Whereas a string being just a sequence of characters, does not have to have some value. Our string could be, we don't know, it's just some empty memory for now, right? Does that make sense to Stefano and Alex?
Well, I was just gonna say, if you take this out and put it in a notepad really quick, just the code that you have written in here, I'm just gonna copy and paste my own here if I can.
I have it copied. You can go.
Cool.
Oh, good. I was taking screenshots, but yeah, kind of.
So with the code that I have printed here, it literally will print out how much memory or the biggest number you can possibly put or the smallest number you can possibly put, which by any means. Did I not put console write line?
You have to put read so it doesn't just
Yeah,
immediately end.
that's right.
So if I hit play,
What version do you have? Do you have
19.
2016? 19? Okay. Anyway, but yeah, if you just print this or if you just pop this into your, Visual Studios really quick, it'll literally just tell you. But again, you shouldn't need numbers that are either that small or that big. So
But yeah, I have it pulled up on stream if you're watching stream.
yeah,
What Alex getting across here is that integer has a fixed amount of memory. We're not. I would love to get deep into how binary works and how these things are stored. I just don't think that's a topic
okay.
for C# specifically. But
Nope.
you are getting the point across here. Great. This is the minimum value that an integer can hold, and this is the maximum value that an integer can hold. Okay. Okay. So what about what I've just talked about of how things are initialized? And, let me give you some wording here. I can hit Control Z, right? Aha. That's weird. It doesn't delete your stuff if I Control Z. Your like copying is not the same as mine. Okay, so this is a variable being declared. Man, I can never remember the wording for this. This is a variable being initialized, right? Declared means memory knows about it. Initialized means it has a value. Does that concept make sense?
Yeah, I mean it's literally you're just saying integer y equals 1, and then again integer is x.
Yep. So even if I don't put anything here, this is not equal to null, right? Whereas if I do string is a nullable type, right? So this guy will be null if I don't put anything. However, an x or an integer has some default value. It might be 0, right? But it has some value. So basically everything except for primitive types, integer, float, Boolean, and I don't think char is a default type. These are the most basic types, also called primitives. Primitives meaning they're very basic, right? They're like the core of what everything makes of what makes up everything. You can make any type of object with these things, right? Let's take a dog for example. We can have an integer for the number of his legs. We could have a float for the length of his hair, right? It'd be 1.1 inches. We could have a boolean for whether or not he's alive. We could have I guess we don't need a character per se. A character is okay. So a character in C# looks like this. It is one letter, and characters in C# are UTF or Unicode. Um, Unicode is like we'll go look up Unicode. I want you to see an example of what it looks like. Basically, it's a list of what values correspond to what character. So if we go look up UTF-8, we'll just go to Wikipedia. It's basically going to be a table of all the values, right? So 0000 is null, 0061 is A, 0062 is B. So this is like if you're using iPhone or Windows, maybe they're using a different character. Man, what are the name of these things? Transformation format? Character encoding, that's what I'm looking for. They may use different character encodings, right? So maybe instead of 0035 being 5 on iPhone, it's an emoji, right? You can have these characters mean whatever you want. It's just whatever format you're using that prescribes what this table maps to. So in this case, my character in this case is C. And you know it's a character if it has single quotes, right? So if I want to do a string is just a string of characters or multiple characters, right? So we could say this is a string. If we wanted to break this out into characters, so if we say my string, I don't know if this is going too far. At 0. I don't know if we're not going to cover arrays quite yet. We'll get there. But basically, what this is saying is, if I want to get the 0th character or the very first character, which in this case would be t, if we hover over that, we can see if we pull it out of a string, it is each one of these characters is a char or a character, right? A string is just a grouping of those characters. And okay, so you might be asking in your head, what happens if I just keep typing, right? Is there any maximum to how big this memory space is? Well, technically yes, it's however much RAM your computer has. But this is kind of like a dynamic type where it's not like an integer where it says, okay, we are 32 bits in memory. String will keep dynamically resizing and giving itself more memory as you need it. And that's built into the common language runtime, I assume. Like your .NET, if you run this application and you were to just keep adding values to this string, right? The .NET framework would say, hey, yo, operating system, can I add another character to this? And it'd say, yeah, dude, we got memory for that. And then at some point, it'd be like, whoa, we're full on RAM, don't do that, right? Hold on, let me catch up on stream chat real quick here. Feel free to ask questions. Yeah, so Basil asked a good question here. Zach brought up that in, I think he's talking about RuneScape here. The maximum number of coins that players may hold in a single stack is 2.1 billion, right? So that would mean if we go to the calculator, and if we're going to go to scientific, we want to go to programmer, we can go to, let's copy his number. This is just kind of for funsies. It didn't copy the 2. Oh, I didn't copy the 2 because I'm bad. Aha, so this is his number, right? That would mean if we took it to binary, this is what the binary of 2, 1, 4, 7, blah, 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 blah equals, which you can see it has 4 bits. So 1 byte, 2 bytes, 3 bytes, 4 bytes. bytes are 4 bits, right? So this is a 32-bit integer, right? So what he's saying is that in RuneScape, the maximum value you can hold is this, right? Because the first bit is either 0 or 1, meaning positive or negative. Because it's a signed integer, right? Meaning the first bit is whether or not it's positive or negative. 0 meaning negative, 1 meaning positive, I believe. Other way around. 0 meaning positive, 1 meaning negative. Yeah. So yeah, Basil basically said he remembers playing a game where that actually was the maximum amount of money you could have, but this is but is the number saved in the stack as a binary number of zeros and ones? Yeah, and the answer is yes. In every game you play, any number that you see on the screen is actually stored as zeros and ones. So you can see some funky things happening, like in Rocket League, for example. I'm not 100% sure if this is the case, but for sometimes you'll have 33 boost, and if you pick up a boost of 12, it'll give you what's 33 plus 12? 45, and sometimes it'll give you 44. Like sometimes it'll give you 11, sometimes it'll give you 12 boost, and that's due to floating point rounding. Or binary rounding. We could go into how that works in the future if you guys are interested. But that's due to the way the data is stored. Okay, so we went over all the primitives. We talked a little bit about how these things are stored in memory. Do those concepts make sense so far? Alex, Stefan?
So, I mean, in my case, so I went to school, once upon a time after I graduated high school for this. So, I mean, C sharp. If you've ever worked with Java, I mean, the primitives are pretty much the same. I mean, we're still in a realm where I still understand because of the previous, knowledge that I have from it. So, I'm
These
pretty okay.
these things will be common in just about every language. You'll see some
Right.
others. You'll see double a lot. And double just means if float holds 64 bits, double holds 128 bits, so our decimals can have more precision. Instead of bool, some languages will call it the full name boolean. But yeah, they're very minor differences, but the core concepts stay the same.
Right.
Yeah. No, I think my YouTube stream is a bit behind, but yeah, I'm following along, limping along, really, but I'm doing it.
Sorry, the stream is a little behind.
That's okay.
Okay, so let's go back to our tutorial because I'm getting sidetracked here. Okay, we were talking about how types are declared. Okay, I wrote this guide, and as we're doing things, I'm realizing that I didn't do this in the right order. So we're gonna adapt. So back to what we were doing. An integer is a type, right? This is saying this object, we're going to refer to it as x. It doesn't matter what the name is. We could put whatever we want. Ooh, okay, we can't have spaces in the name. C# says we have some guidelines. We want the first character to be lowercase, and if we're going to do words, right, we're going to say this is a number. It's called camel casing, meaning the first letter of each word is capitalized. Those are stylistic guidelines. You could have them all lowercase, and the program would function fine. But if you have a team, this might be kind of hard for them to read, right? So you kind of want to think about that. Okay, so back to what we were talking about. This is the reference to that spot in memory, and what's in that spot in memory? An integer. Okay, what's in that spot of memory now? An integer of 1. So what's on the left-hand side is the type of the thing. This is just how we refer to it. It can have whatever name it wants, and this is whatever the value is. So now we can get into a little bit more complex, and we can start thinking about how to make our own types, right? If we pull open this drawer over here and look at our solution, what we currently have is we have the solution, which is kind of wrapped around our project. It gives us like extra metadata of like where the file is stored and stuff like that. We have the actual project itself. We have the properties of a project. We can open that up and you can see this is the assembly info. This is like how the project is built, the name of the project, things like that. It's not necessary to know what's inside of these things. We have our references, which are the things that we depend on. For example, we depend on system.core, and so on. These are built into the .NET Core. We have our config. You won't really need to worry about this. This is just saying what our version of the .NET framework is. Then we have our actual program, right? Our program.cs file, .cs meaning .c#. So what we can do then is we can right-click on our project. We can add a new item. And that item we want to add is a class. And I like using the idea of animals in this. So we're gonna stick with, I don't know, we'll make an animal farm or something, or a dog show or something. I don't know. You can see it automatically imports things. If they're dark gray like this, it means their import is not being used, so this is unnecessary, so we can delete all of them. And then we have this namespace thing. This is just a logical way of grouping things, similar to packages in Java. I don't use them terribly often. We're not going to worry about them in the console applications. If you guys are worried about how they work, we can talk about them separately. So we're just going to go ahead and go with a class. And what do we want this class to be named? I don't want to rename the class here. I want to rename the file itself. So if we go to the file and click rename, we can name it animal. And as soon as I hit enter, was it the other way around? Should we have renamed the class and it renames the file? I don't remember. One way or the other. So if we hit save, now the class name matches the file name, right? So what would an animal have? We would have what type of animal it is, maybe its lifespan, those type of things. So let's try and figure out how we would classify, or what types of things does this classification have? All classifications can have a way to create it, its properties, and its methods, right? So we have its properties, its constructor, or the way we can create the object, and then we have its methods, or what things this classification can do. So let's go ahead and save here and go back to our program. So now we could say animal, my animal. I don't know why. It wants me to name it animal. Okay, equals a new animal. Okay, so what does this do? This says I want to, we're going to read this like it's English. I want to create an object of type animal. We want to reference that by the word animal. I want to change this so that it's a little bit more clear. We'll call it my animal, so it's separate so it doesn't confuse you. So I want to create an object of type animal. We're going to reference that using the name my animal. And what is that going to be set to? A new instance of animal, right? So from nowhere, we want to construct an object of type animal. Well, what does that thing hold? Currently, nothing, right? If we do my animal dot, the only things that are there are the things that we inherit from object, right? Because animal is a class, therefore it automatically inherits from object where we started our talk here, right? For example, let's just go ahead and type out get hash code, and let's just see what's inside these things. I've never used hash code. I've used toString a lot. And let's just output these to the console and see what they say, because I'm a curious fellow. Get hash code is an integer, so we will say int hash code is that hash code. And notice how this will still work without the space, but I like the space to keep it consistent. And then toString is going to be a string, and we'll just call it toString. So let's print out the hash code and put a space between them, and then put the toString. Let's see what it says. I'm dumb and didn't put a readline. Okay, so our hash code is just some random set of numbers, so that way we know this object is unique. And then the default toString looks like it's just the name of the class, right? So if we hover over toString, returns a string that represents the current object. So what we could do is we could make this toString do whatever we want, but default it just prints out the name of the class itself. Daniel Clemente asks, what are the main advantages of writing something in C# as opposed to using a cross-platform language like Python for things beyond relatively basic things? That's a really good question. Let me figure out how I want to word this. So the main advantages, in my eyes, are the ability to use object-oriented programming. And we're just getting into the basics of how objects and classes work. Python has a conception of them, but they're dynamic, so they could change at runtime. Like I could just say animal, my animal equals animal, and then in Python, I could say my animal equals 1. That doesn't make any sense, right? In C#, it'll say, wait, you're trying to set an animal to 1? That doesn't make any sense. An animal, it can't be an integer. They're not the same thing. In lots of dynamic languages, you can do that. So how do you know when you're looking at this variable what it is? Well, if I hover over my animal, I know it is of type animal, right? And that's a beautiful thing to know what is inside of an object, like what it consists of. And to be able to debug things and be able to read through someone else's code, I personally think that it is much easier to read when you know what types things are. On top of that, I think Python, much like JavaScript, has a lot of capabilities, but I think it almost gives beginners too much capability. Because, for example, if they just said my animal equals 1, like we talked about before, oh, well, that just I read this guy and then I read this guy, and now you're looking at this like scratching your head like what is this person even trying to do? Whereas C sharp completely prevents that from even being a probability. They can't mess that up, right? So that's another really nice part about it. Um, as far as like performance goes, um, I don't know. You guys want to look up benchmarks? I know. Okay, nothing is going to be as fast as C because you can actually take care of the memory itself. But I want to know Python versus C sharp speed. I'm curious. This isn't something I usually concern myself with because I'm never trying to eke out that last bit of performance. There's nothing that I'm doing that's scaling that much. I wanted a benchmark graph. They don't. Sad. So it is okay. I'm probably gonna find the same stuff, but it is kind of hard to compare two languages because, like, let's just say, for example, I want to compare how fast C sharp is at adding two numbers and how fast Python is at adding two numbers. Those two things can be comparable, but like maybe in Python you're using a library to add those numbers, which isn't representative of the speed of the actual language. So performance isn't something that I'd care about too much unless you're doing something that is absolutely a requirement of performance, like making a game and needing to eke out every single inch of performance you can for shaders and whatnot. Um, Elon, yeah, you're probably right. Python should be slower because it's not compiled, meaning it's not. So when I hit run, right, it doesn't just like go line for line and read my code like it's English. It takes these and it turns it into bits and bytes and says these are the instructions that I need to execute on the operating system. This guy, it says, okay, hey, Mr. Operating System, will you create enough memory to hold my animal thing? Yeah, sure. Hey, Mr. Operating System, will you set my animal thing equal to whatever a new animal is? Hey, Operating System, will you go into my animal and um, grab whatever the hash code is and then put it into here? Um, the compiler turns that into these each of these statements into sequential instructions to the operating system on what to do. Whereas in Python, it doesn't. It doesn't compile and optimize like that. It's I think it's an interpreted language. Is how you would say that. I'm absolutely awful at knowing those language level differences. That is something that I'll happily look into for you and come back with a better explanation. I'm not going to pretend like I know the best answer to that. Um, also, I think I kind of glossed over your question here. Um, cross-platform, I believe, was more of your question there. Um, C sharp, if you would have asked me 3 years ago, I would have said don't use C sharp for cross platform because .NET Core wasn't there all the way. Basically, what they're trying to do is they're trying to say, okay, cool, we made all of these functionalities for you to be able to make .NET applications on Windows. Oh, wait, now we have to think about like how we're going to do that on Apple. Ah, crap. Now we got to start pulling out each individual piece of functionality and making it work across those and making them maintainable. They weren't at a solid state back then. With the new .NET Core 5 that's coming out soon, they're adding interoperability with Swift. They're making it completely cross-platform, completely open source, much more stable. A lot of the bugs are hashed out. So it would be a great language to use for cross-platform. However, how cross-platform are we talking? Are we talking mobile? Yeah, I don't know if I'd use C# for mobile because they're using Xamarin, and there's a lot of boilerplate. You're going to be fighting a lot of bugs, whereas in native, like if I'm coding an iOS app, I'm going to be using Swift. I'm coding an Android app, I'm going to be using Java or Kotlin, and they're more geared to handle those things. They're more geared to work with the way their UI works and the way they store data. Um, so it's really about finding the right hammer to hammer the nail that you're looking at. If you want to do data science, Python is just as good as any other language. Uh, okay, that was a really blanket statement. Python would have the same capabilities as C sharp. However, maybe Python has a library that people have built up to handle that thing for you. So that's a consideration, right? You don't want to reinvent the wheel. You don't want to spend tens of thousands of hours doing something that another developer has already done for you. Um, so if I had to say, if somebody said what language should I use, I don't say C sharp right away because that's not That's not the smart decision, right? There is no one language that fits all. However, what I would do instead is to ask you some questions about your goals. What platform do you want to go to? Do you want to go to iOS? Okay, here's what you can think about. You can go to Swift. You can use their older language, Objective C. You could use Flutter, so you could build a Swift and Android. Oh, you wanted to build mobile apps, but you also wanted to work on a website? Well, why don't you just build a website, because a website can be reached from a phone? Okay, how would you want to build a website? You already know JavaScript? Cool, use Node for your backend and React for your front end. Like, I would need to know your goals depending on what you want to do, and they're really fluid, right? Because new frameworks and whatnot are popping up every day. So it's almost a one-on-one discussion that I need to have to tell you why one language is better than another for certain things. And I hope that wasn't too long-winded. Any other questions while we're talking about that? I got off topic.
Only real difference, like from knowing Python and now getting into C sharp, is just aesthetically talking or speaking. C sharp is much more visually appealing than Python. Python just has too much white space for me. I don't like it, so that's
Uh,
really the only difference I can tell.
when I first started in Python, I was like, oh, cool. I don't have to use semicolons. I don't have to use brackets. Um, I liked that because I was like, oh, dude, I'm saving like a character every time I'm writing a class or something. And when it came down to it, I'd rather write that character and have my mind used to that styling because I can read that code faster. I'm going to spend a lot more time reading code than I am writing code. So me as a
Right.
developer, I want it to be as readable as possible. Um, Elon Tusk said, "Got any tips on how many classes to have in your program, separating everything, or amalgamating certain similar things?"
I feel
Um, that's going to be a much deeper topic when we get to design patterns. Um, that is not something that I want to talk about with some of the beginner level stuff, but write that down for when we get to it. I mean, you may not even have to write that down. We're going to get to that. Don't worry.
that has been the hardest part for me, is like coming across something and then your brain just thinks of something, and obviously it's a way more advanced step than what you're working on at the time being. So like right now, if you're watching this, obviously you're still in the beginning steps. You don't really need to know how many classes you need to have and stuff like that. But I was the exact same way, so I'm not bad mouthing them or anything.
To give you to just give you a very brief overview, there's a few concepts that you can look at. You can look up out there for design patterns. The first one's called solid. I don't want to go into each of the principles that it enforces. But there are a few patterns to look into. I'll type them into the stream chat so that way you can Google them yourself and watch some videos on them because they are pretty deep. So I'm just gonna type in. I don't know if they're considered design patterns or more architectural decisions. I'll just call them architectural decisions.
That aesthetic though.
Decisions. The first one is called solid. There's also Yagni, dry, and I don't remember what the last one is. So basically, what you want to do is, let's say you're programming something, right? We're making an animal, and maybe an animal needs to have some sort of stimulus to check on whether or not it's alive. Um, that's a really bad example. We're talking about man, what is a good example of this? Basically, you want to code everything as simple as you can your first pass. Put it all in one class if you have to. And then as soon as you need to use it a second time, well, you're probably going to need to use it a third and a fourth time, so break it out into its own function or its own class. Ideally, you'd want to have things it's called the single responsibility principle. You want things to only be responsible for themselves. If I'm making a game, I don't want my game manager to be responsible for my player movement. I don't want my player movement to be responsible for keeping track of the player's score, right? Those things should be separate and on their own, and they should only worry about their data. They shouldn't have to worry about interacting with other things. They should just store their data and figure out what to do with it, right? I use games as examples a lot because they make sense to me. If you don't like those examples, I can come up with more. Okay, we kind of sidetracked a lot. While we're on the sidetrack, before we get back to talking about classes, are there other questions I should answer?
I mean, as far as the classes thing go, I mean, it just, if you do decide to make a career out of this, they're going to look at your code and it's just going to look like a jumbled mess if you don't break up the classes. From what I'm understanding, that's where you're going with Sabian.
Yep. I typically try, as just a rule of thumb to myself, if my files get over like 200 lines, I'm gonna start thinking about what I can break out and bring on its own, right? Because that 200 lines, like, it's not I want to be able to look at this class and say, okay, this is a game manager. What does it do? It keeps track of the current time and updates the score. That's all it should do. I shouldn't have to be worrying about all the different things it does and having to try and understand them and keep them in the same context in my head at the same time, because that's just gonna it's gonna be room for error, right? Like something's gonna go wrong. I'm gonna get one wire crossed and I'm gonna mess everything up.
Before we get too off, or before we end this topic, AA wants to know, what does static and void mean?
Yeah, that's a great question. I kind of glossed over them because they are a little bit more complex, and we're going to get to them here in just a second. What static means, I'm going to give you an explanation of them, and then we're going to come back to them in the context that they make more sense. Static means you don't need an instantiation of program to access this method. Void means this function doesn't return anything. So in this case, our main function, it's going to take in some args, just means arguments, and it's going to take in an array of those, right? Array of strings. So you can put in arguments, like if we're in the command line, you could type in, program should take in, how much memory it's allowed to use and whatnot. And then it's not going to return anything, so it's void. And it's also static because we don't create an instance of program. Program is just ran, right? Whereas in my animal class, um, we'll go ahead and go through my class example, so this will make a lot more sense to you. So, an animal, what type of properties would it have? We'll just start out easily, and we'll create a boolean for whether or not this animal is alive, right? And then we'll create a constructor, which allows us to create a new instance of this object. I'm gonna go through these, and we'll come back to them so they make more sense. And then we'll say, um, we'll create a method that should say whether or not he is alive. We'll keep this simple for now. Okay. Elon Tusk said, "What's the difference between string builder and string?" Uh, String is fine for the majority of use cases. String builder is used when you're going to be building complex strings and it's less memory intensive. That's not something that beginners should worry about, but he asked the question, so I had to answer. Okay, so what is this class doing? We have a boolean, right? And this is going to track a property of the animal. Is our animal alive? It's going to be true or false, yes or no. And we name the variable appropriately. Is he alive? Is a yes or no answer, right? If we just put alive, like what does that mean? I want to be as descriptive as possible with my variable names, so we're going to put is alive. And now we have the constructor, which is what's going to allow us to create this object. I will go ahead and this is a lot of this stuff is going to like freak you out. I want you to just bear with it until I can explain what's going on. So the constructor, when we call the word, let me delete all the code that I can to make this as simple as possible. When we create our animal, we say this keyword new, and new says you have this animal class that has certain properties and methods, but you don't have a specific instance of one, right? You could have multiple animals. If we're creating a zoo, you could have multiple animals, right? We don't want just one. So when we call new, we create one of those animals, right? In this case, we're just creating my animal. So we'll call it a we'll give them names for now. Um, we'll call one a lion and we'll call one a dog. So we're gonna we're gonna sidetrack just a little bit. In Visual Studio, this gray bar on the left-hand side, if you click on a line, you'll see it puts this red circle and it highlights the line red. And what that does is it puts in a breakpoint. And what a breakpoint is it says, okay, when we hit this line, we're going to stop executing our program and we're going to allow you to look at the current state of what's going on. So when I hit start, you'll see this line turns yellow and we have this little yellow arrow here saying, hey, this is where you're stopped. Do you want to continue? So what we're going to do is down here in these options, if you click on locals, these are all the local variables that we have access to. Locals meaning they're either defined in the parameters or they're defined inside the class. If we were to assign something up here, such as I don't know, let's call int x equals 0. This would not be a local variable, this would be a global variable, because any methods inside of the program have access to it. We'll come back to that. I'm sure that doesn't make any sense right now. So we have a list of arguments, and you can see it's just an empty string. It's a string, and it has 0 here, meaning it's there's nothing. There's 0 elements inside that array of strings. And then we have a lion and a dog, and you can see the name of the variable is lion, the column, and the second column is the value. The value that it holds is an animal. Well, what does an animal hold? If we open up this little arrow, an animal holds whether or not it's alive, and in this case, it's false. And we know that because when we call this new function, it calls the constructor, and the constructor says, we're going to create an instance of this object, and what are we going to do when we do that? We're going to set is alive to false. If we change this to true, and we rerun, and we hit that breakpoint again, I don't know what I did, hold on. And I open up lion, you'll see is alive is true, right? So basically what the constructor does is when you call new, it starts here, and when it's done, it doesn't have a return type because that's how you signify that it's constructor. But what it's doing is returning an instance of this animal, right? The return type is an animal, and we're returning an animal whose is alive property is set to true. Now that we have an instance of that object, we can call methods on it, right? Whether or not it's alive. So now if we go back to our program, we can say lion dot is alive, right? And I'm gonna clarify this. Is alive is the same name as the variable. It doesn't have to be. So we can just say get is alive. So we want to return whether or not it is whether or not this animal is alive, right? So if we go back to our program, if we do lion dot, you can see get is alive is now an option because we created that function, and now we have access to it on the instance of that object. And we know I'm trying to cover a lot here, and I know this may get a little confusing. The function itself is public, meaning it can be accessed outside of the animal class. It returns a string, and the name of this method is as such. Inside of it, what do we want to return? Well, our return type is a string, so we're just going to return the word yes. If we were to build this for real, we'd want to check whether or not we are alive and return no if we're not, but we'll get to if statements later. So we have access to this get is alive method because we have an instance of our object. An instance, I feel like I've gone over this 100 times, but I want to keep drilling it into your brain. An instance is a living, breathing copy of our object that has different values set, or it has some values set based on what was either in the constructor or what methods you've edited on it, right? So in this case, lion.get is alive. This should return yes, no matter what, right? We don't have any if statements checking whether or not we're alive. We're just returning yes, right? So if we just console.readline, or if we output this into string lion is alive, the string that this holds should be equal to the word yes, because that's what this function returns, right? You know what type it returns by what's directly before the method name, and you know what it returns by the return statement. So if I go ahead and hit run here, if I hover over lion is alive, you can see what the value of it is, similar to lion. If I open up lion, you can see is alive is true. If I hover over lion, you can see the value of it is yes, which is exactly what we expected, right? Maybe change maybe change is alive to is hungry. It seems less dark. That's fair. We can do that. Oh, now what's going to happen when we do this? Oh, we don't know what is alive is anymore because it doesn't exist. So what should we have done? Oop, oop, oop. If we go back to where it exists, we can right click on it and rename it to is hungry, and it will change the references that we were looking at. Okay, so Elon does bring up a good point that we were going to have to hit on at some point. Sometimes you see constructors that perform operations on stuff. For example, in our constructor here, we're setting hungry to true, right? Default if we hover over this, we could just not have this. We could just comment out this line, run it, do, and hover over the lion and check if he's hungry. And Booleans default to false, right? Like similar to integer, Booleans cannot be null. They have to have some value. A Boolean is either true or false, nothing else, right? And in C#, it happens to default to false, which so be it, right? It really doesn't matter, right? Well, when we do this guy, we're setting some property of it when we create it, right? So when I feel like I'm flipping back and forth between these files, I'm going to set them next to each other, and I just did that by clicking and dragging the name of it. So when we call this new, what it's doing is really going through this function. And you could see when I ran it beforehand, the lion's is hungry attribute was set to false because this line was commented out, right? Because the default value of a Boolean is false. If we do this, it will now be true because when we call the new animal, it's calling this method. And it might be a little confusing because you're like, oh wait, we have to call lion.getIsAlive, but why don't we do lion.newAnimal? It's just the way the languages have been constructed over time. If we want a new instance of an object, we put the new keyword in front of it. You can see the keyword is blue, meaning that it's going to create a new instance of it, and then the type of the thing that we want to create. Okay, so back to your question: is it good practice to initialize properties from parameters, or is it better to do those in separate lines? That really depends. I personally don't like to have more than 2 parameters in any function. That tells me that I'm doing too much. However, it would make sense that if I'm passing more than 2 parameters, I could just pass in an object that has multiple values and I could set it as so. Can we give lion a new constructor and assign it a value in the main part? Okay, that's what we're getting to. That's what we're getting to right here. Okay, so so lion is an animal, right? That doesn't make sense. A lion should be a lion. A lion has its own properties, right? So let's create a lion class. So we're gonna go to C# tutorial. We're gonna do add, and we're gonna create a new item, and we're gonna call the class. I didn't have to rename it if I would have just done it down here last time. So I go to lion and I hit add, and we're gonna go ahead and add dog too, because that's the other one that we have. They're gonna do different things. We'll just knock this out of the way. Okay, so we have our program, and we're gonna create, instead of an animal, we want to create a lion, right? But what is a lion? Hold on, let me clean up this file. A lion is an animal, right? Logically, in English, a lion is an animal, right? So what do? This is going to be scary. A lion is an animal. That's what this says in C#. We're creating a classification of a thing called lion, and that thing inherits from animal. So if I hover over, I thought if you hovered over lion, it would say its parent class. Never mind. Okay, so in lion, what does lion have that an animal doesn't, right? So a lion is more specific of a categorization of a type of thing than an animal is, right? So we could have the category shape, and we could have subclasses called circle and square. In this case, we have a parent class called animal with subclasses of lion and dog, right? So lion has access to, I lied. If we go to animal, you see how a Boolean doesn't have an access modifier on it, meaning it just has a default. I am struggling to explain this without going too off topic. We're going to put public here. And what that allows us to do is in the child is, I have to access it inside of something, sorry. So we can do public lion for when we're creating some sort of lion. And in here we could set his is hungry to false, because lions are never hungry. Lions are never hungry, they're badass. But what would lion have that dogs would, or that other animals wouldn't? Maybe he doesn't have a property that others do, but maybe he has a function called roar. And what does that do? We need to import system. And we want to write out to the console. I can type, I promise. Roar. So the lion had. We're printing out to the console. We're not returning anything, right? If that doesn't make sense, we can go deeper into it. But so the lion has access to this roar method, but the animal doesn't, right? Because the lion is more specific of a type of an object than an animal is, right? So if we go back to our program, and I'm going to pull this guy over here off on his own, and then put all the subclasses on the other side, so we can always see the main program. So a lion is an animal, right? But what we really want to do is we want to make this guy a lion. Does that make sense? So notice, I'm going to go ahead and get rid of animal. Notice how we can still call get is alive, because lion inherits from animal, and animal has get is alive, right? So any subclass, lion being a subclass of animal, can access its parents' things, provided it's public, right? A child can access its parents' things, but a parent can't access its child's things, right? Like, what would be another example here? If bird and plane are a parent class, or are children of flying, um, they could both access the fly method, but maybe bird can't access turn on your jets method, but plane can, for example. Okay, so now we have access to the roar method, right? So if we do lion dot roar, oh look, it shows up, right? The autocomplete of Visual Studio knows what your classes are capable of, right? So if I just do roar, and I hit F5 to run my program, and we stop right here, and we go, oh hey look, it printed out roar, right? Because all our program does is we create a new lion, we get whether or not he is alive. We don't do anything with it, right? We just have this stored as a value. We haven't printed it or anything. And then we called roar, right? Well, if now I go in and I say dog is a new dog, and that's going to freak out because we haven't actually done anything with our dog yet, and it's in a different namespace. So we're going to go back, and we're going to clean up this class, and we're going to create himself a constructor. Okay, this guy doesn't freak out anymore. Okay, so now if we do dog dot, we forgot to make the dog a child of animal. Okay, if we do dog dot now, you should see we can get whether or not he's hungry, we can get whether or not he's alive, because that's in the animal class, but we can't tell a dog to roar, right? Because a dog is not a lion. Does that make sense? I feel like I've gone on a long time. I'm gonna stop and make sure you guys aren't curious.
Hey, no, just following along.
Okay,
It's all good.
all right. So
I think later on when we kind of we'll do like another session, like probably go through some stuff again, but keep going.
okay, and that's kind of the hard part about programming, is I have to dive too deep, and you're gonna miss some things. So we have to back up, and then we have to redo it again. It's kind of this weird red light green light approach where I have to kind of teach you new things without you knowing other things, but we have to catch you up. It's a pain in the butt, but we'll get you there. So now, maybe lion doesn't need to roar. Maybe all animals just need to make some sort of noise. We're being a little bit gracious of this because I don't know, maybe we're talking about a sloth or something and they don't make noise. But we're gonna assume in our system that all animals in our, you know what? Let's get funky with it. We're gonna rename our class. We're making a zoo. And in our zoo, we have a lion and we have a dog. And we want our animals to make noise. So rather than roar, we want all animals to have this function called make noise. And all it's going to do, actually, we don't want this function we don't want an animal to make noise. We want the specific animal to know what noise to make, right? So we will just call, I'm so bad at remembering to add these things. There we go. Okay, so now we have access to console. And we're going to say animal made noise. So now we could go into, we don't want to return anything, we just want to return nothing, but we want them to write. Okay, so now we could say, let's keep it simple. Let's say lion dot make noise and dog dot make noise. What logically makes sense to happen at this point? They're both going to print out animal made noise, right? Does that logically make sense? Boop. because they're both doing what animal tells them to do, right? However, okay, this is where you need to bear with me, and it gets a little different from Java. If we add the keyword called virtual, this is similar to abstract in Java. This is saying, um, if you're going to make me an animal, here's what I'll do, but you, as a child of me, can override me and tell me what to do. So now we can do public, and now we have to add, since that's virtual, we have to override that virtual function. So now we have to add the keyword override. And now you see, oh, you want to override something? Cool, we know what you can override. You can override make noise. So you can call base.make noise. Base meaning, you see how when I hit base, it hovers over animal? Base is our parent, right? In Java, this would be super, right? Referring to our super class. Well, we don't want our base to tell us what to say. We want a lion to print out roar. And we can delete roar now, because this is how he's going to make noise. And we want a dog to say woof, right? I didn't copy over system. So now, I'm going to get rid of these breakpoints, and I'm going to get rid of this guy, and we're going to keep this simple. Okay, now if we run, we should see the lion said roar, and the dog said woof, right? Lion.make noise doesn't call the make noise, like, notice how animal made noise is not even being called, right? Because we said, hey, Mr. Lion, you're the one that's going to make noise, right? You're the child, we overwrote that function, and this is how you should do it if you are a lion, right?
Hold it.
I'm mad at you, Alex, I have to look this up.
Hold it. Hold it for a second.
What does a sloth say?
Oh no, don't watch it. Not
Yeah.
now.
I'm gonna look it up later on my own time, but I'm trying to keep things fun in here. Like, I don't want anybody to get bored. I want you guys to be able to ask questions and have fun with this. I don't want to be too professional about it because people will get bored. So feel
No,
free
yeah, I
feel
just
free to be fun
haven't.
with it.
No, please watch it now if you're gonna do anything.
Okay, so does the individual classes themselves overriding that function and telling them what to do make sense to you guys?
I'm almost there. Hold on.
Okay, sorry. Yeah, the stream
You're
is
fine.
behind.
Da, 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 da.
Oh, Elon, you're gonna make me dive into the depths of my knowledge on object-oriented programming here.
Don't do it.
Okay, so Elon asks, could you explain the difference between overriding, overloading, and polymorphism? These are concepts that, if you're going for an internship or a junior level developer job, you'll probably get these questions a lot. So, overriding. We overrode, or we override a parent's method. If we want to overload a method, all that means is we change the parameters of it, right? So, we can copy this guy, and we can say, noise to make. And rather than printing out animal made noise, we can just print out the noise that we want them to make, right? So now, if we say lion.make noise, you can see, oh look, we have two options now, one of two. If we hit the down arrow, oh, we can pass in a string. And the string we want to pass in is, I'm making noise. So what we'd expect the output to look like. Roar, I'm making noise, woof. I'm calling it, I messed something up. I did not. Okay, cool. So, overloading says you can have multiple methods with the same name, but if their method signature, meaning either their parameters or their return type changes, they can have the same name, but we're overloading what their capabilities are. So, like, I could have this kind of makes sense, right? I want to. This doesn't make a lot of sense. Okay, let's take that random method that we were talking about earlier. Maybe we want our random to be between 0 and 100 of integers, or maybe we want to be doing floats, right? Decimals. Maybe we want it to be between 0 and 1, right? If I overload my random method, I could have it take in 2 integers for the min and max, or I could have it take in 2 floats for the min and max. That would be one use case. I could probably come up with more examples to solidify this better in your mind. And then polymorphism. Poly meaning many, morph meaning takes different shapes, and ism meaning I don't know what that language breakdown means. But so polymorphism means that this thing behaves differently depending on what shape it takes, right? If I'm an animal, the thing I do is this. If I'm a lion, the thing I do in this polymorphic state is this. If I'm a dog, I do this, right? Polymorphism basically means you do different things depending on which level in the class hierarchy you're in, right? So maybe a subclass of dog would be golden retriever, and then instead of saying woof, he'd say bark, right? And he would override this even further, right? That would be an example of polymorphism. Questions before I go on? I feel like some people are like, "Oh hell yeah, this makes way more sense since last time I heard it," and other people are gonna be like, "I'm so lost, I have no idea what's going on."
Yeah, I think I sort of fall latter category, but I think also that other course you were talking about, the sort of the basics of computer engineering thing that you were going to do or something like that. I think that's sort of more my speed. But I am, I'm a firm believer of just diving headfirst into stuff, and I think I'm just trying to absorb as much as I can.
Okay. If you stick around till the end, we'll go make some console applications and we'll revisit some of the smaller level stuff and we'll make really small applications. I just want to go through each
Yeah,
of the concepts and
definitely.
then we can do smaller examples of each one of them so these concepts kind of solidify, right? Like if you see, oh, this guy has make noise and this guy makes noise, at what level are these things pulling from? And the more examples you see, the more you can kind of figure out where things are happening.
Yeah, sure. And I don't want to like hold anyone back. Keep going, and then I'm taking notes, and then I'll ask questions later.
Okay. I said he'll watch this tomorrow because the voice is going too fast. I'm sorry, I talk really fast. Just yell at me to talk slower. I'm sorry. Andre said, "Sorry, can you explain virtual? I may have missed it." Virtual. So let's revisit our hierarchy. I'm gonna pull up Paint again because I like having visual examples of what's going on. So I'm gonna use abbreviations because I don't like writing a whole lot. A is for animal. D is for dog. L is for lion. So our parent class is animal. Our children are dog and lion. Animal has the function called make noise. Blah, 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 blah. Lion and dog should also be able to make noise. So if you make the function virtual in the parent class, that means lion can tell that make noise method what to do. That also means that dog can tell that method what to do. Good night, I. Thanks for coming. I hope that makes more sense, Andre. Feel free to have me try and explain that in a different way if that didn't make 100% sense. Okay, back to what we were doing. So, we understand now that the goal of object-oriented architecture is to create objects that allow us to classify what our classification of thing should do and what properties it should have. And as we get into subclasses or children, those terms are synonymous, those classifications get more specific due to them having, how do I phrase this? Due to the classification getting more specific, right? Like similar to like in biology, like genus, phylum. I don't remember what order they go into, but as they go down, they get more specific, right? Um, okay, so I think we have some ideas of how these things work. Let's come up with some ideas on how on like let's just say something that we'd want to do. What is something that we would want to make that sounds super simple that we could make an example of? Like, do we want to keep with our zoo reference, or do we want another conceptual reference to make these things more solid in our brains?
I like the zoo thing. I think it's quite keeping it simple is just a lifesaver for me at the moment.
All right, so we'll keep going. All right, so let's make this a little bit more complicated, right? And by complicated, I mean we're either going to add methods or we're going to add properties. So let's say let's add a function in our zoo to check if any of our animals are hungry. How about that? Like we're gonna tell our zookeeper to go feed the animals, and if he does, all of their is hungry will be set to false. They won't be hungry anymore. And then after, I don't know, 10 seconds, they'll all be hungry again, and he has to go feed them. How about that? So let's say all animals have um, a timer on how long it is until they get hungry, right? So we'll say pub. Oh my goodness. Tab. Yeah. Public float time to get hungry. So, an animal wouldn't know this. A lion and dog would have separate appetites, right? So in a lion, in the constructor, we can say time to get hungry. We'll say it's 100, and we'll just say that float represents hours, I guess. So what we would do in production level code, in high level code, we'd either say time to get hungry in hours, so it's in the variable name, or we'd put it in a comment right next to it saying the time is in hours, right? I'm going to put it in the variable name because I like to be as descriptive as possible. Yes, the variable name may get wordy, but we have autocomplete. We're not writing all that out. I'd rather have it be more descriptive than not. Okay, so now you'll see, since I changed time to get hungry to time to get hungry in hours, this guy says, "Oh, we don't know what that's in reference to." So let's hover over this guy, and it says the name does not exist in the current context. Well, yeah, that's right, it doesn't exist. Let's see what our potential fixes are. We can either generate that field in our class, or a bunch of other things, right? So we can either make that field, or, if we're smart, we can just fill it in, right? So let's say, thank you, Nathan, that is a way better variable name. Hours to hungry. And this kind of goes back to an old adage saying, 90% of your programming time is thinking of variable names, whereas 10% is actually programming. You should put some decent thought into how you're naming your variables, because you want people to understand what these things are doing, right? And you also want them to be concise. Okay, so in this case, a lion takes 100 hours to get hungry. In this case, a dog. So we're gonna assume when they start that is hungry is false. So let's have, for all animals, all of them assume that hungry is false at the beginning. So what we want to do is we want to say base. I forget how to do this. Base dot. I'm googling it. I haven't done this in forever. Call constructor in parent C#. Is it just base? Oh, you put the colon after it. Haha. So this basically says before this guy runs, let's call the parent one. So just to reiterate this fact, we can use our debugger and step through these lines to see what happens. And this is going to be super cool, and you guys are going to love this. So when an animal is created, we want its is hungry always to be false. And we're not going to do get is alive anymore. We're going to say get is hungry. And it's just going to return whether or not we're hungry. Oh, that's super simple. And it's not returning a string anymore. It's returning a Boolean. Okay. I'm going to clean this up a little bit because we don't need this make noise anymore, because we want to keep things simple, right? Like, the animal should not be making the noise. The child should always be telling it what to do. All right, this makes sense. So in lion, we're going to say when we create a lion, we want it to automatically set is hungry to false, right? It should do this line of the constructor, and then it should do this line. Does that make sense? I'm going to operate under the assumption that the answer is yes if nobody talks. So we're going to do the same thing in dog. We're going to call the base. And this is just the base constructor, right? When we're constructing a dog, we want to first construct an animal, then construct the more specific thing, the dog. And we're going to copy this because I'm lazy. And we're going to change the dog's time to hungry to, I don't know, 10. 10 hours until a dog gets hungry. Yeah, I feed my dog like every 3 hours. Okay, so this method no longer exists because we got rid of it, so we will delete it. So now, what we're going to do is we're going to get rid of make noise because we don't need them right now. Maybe like when they get hungry, they make noise. That kind of makes sense. So we're going to create a lion, we're going to create a dog, and then we're going to say, okay, we're going to get into some new concepts here, and we're going to get jiggy with it. We're going to say while true. Never do this ever unless you know what you're doing. What this says is while whatever in this thing is true, do what's inside of here. So in this case, this is going to run forever because this true will never not be true, right? So we could say while is running, and we could say bool is running is true. And then in here somewhere we could say is running is false, right? So we'd say while we're running, which happens to be true, do something. Oh, we're not running anymore. Cool. So we'll exit out of this loop and keep going on. But for now, we just want this thing to keep running forever, so we're just gonna put true. So this is if we're talking about games, I like to add analogies to other things so that way you guys can see where these concepts come in. If we're in a game, we're gonna have some core game loop, and it's gonna look somewhat like this: while true, do something in the game, which could be check for user input, move the AI, increment the counter, like the timer of the map or whatever. So like in all games, you have a core game loop, which is basically a while loop, and when you hit the quit button, it exits out of this loop, for example. Okay. So we're going to say while true, what we want to do is we want to decrease the amount of time that we want to decrease hours to hungry, right? We need two variables for this, right? We need its current time to hungry. Like if we subtract one from it, we don't know what like it. How do I explain this? We need the timer, and we also need the actual value, right? And we don't want the zoo to hold that. We want the lion to know how long it has until it's hungry, right? So we have hours to hungry, and then we have I always just add timer to the end of it. That may not make 100% sense to you. Nathan, if you can come up with a better name, I'll put it in there. Okay, so when we initialize these things, we always want the timer to be equal to whatever the actual number is, and this will make way more sense here in just a second. Okay, so what this is saying is when we create a dog, we say it's not hungry, but it has 3 hours until it gets hungry, and I don't know, we'll say every second we subtract, we're pretending that's an hour, and we'll subtract 1 from that timer. When that timer hits 0, it is indeed hungry, right? And so in animal, we can basically say get is hungry is no longer just what is hungry. It is return whether or not the hours to hungry timer is greater than 0, is less than 0. Basically what we're saying is, it's somewhere in here, we're going to decrease this timer every second, right? And then when that timer hits 0, hours too hungry, hours till hungry. I'm going to leave timer on there. I don't know if that's 100% abundantly clear. But yeah, okay, so at some point, basically whenever the timer is less than or equal to 0, we know this guy is hungry, right? So we're going to say while this guy is true, lion dot, actually, while this guy is true, check if, we're going to say check lion is hungry. Because I don't want to keep putting things in this function, right? I want to keep this clean. So what we're going to do is we're going to make a new function. Ooh, getting spicy. And we're going to call it static void check lion is hungry. And what we're going to do is we're going to say if, oh, that sucks, we don't have access to lion, right? Because we declared lion in here, and you can think of these curly braces as basically C# or the .NET platform has a garbage collector, which basically says anything inside of these brackets, when we hit this last bracket, unless we're using it somewhere else, you can get rid of this memory. We don't need it anymore, right? We're not going to be in here anymore. For example, when the program ends here, we don't need any of this memory anymore, right? So we don't have access to lion. So what can we do? We could pass that lion into the function. So we're saying we have a function called check lion is hungry. It doesn't return anything. It might return a boolean of a true or false. But we're taking in a type of lion and we're naming that thing. We'll call it my lion to make this a little bit more self-explanatory. So when we call the function, right, we're passing in the lion that we created, right? So we're saying if my lion dot get is hungry, if he is hungry, right? So get is hungry should return true if he is hungry, right? So if he is hungry, let's have him make noise. My lion, my lion dot. Forgot the caps. Make noise. And if he's not, we could put an else and do something if he's not hungry. But all we want to do is say if he is hungry, make noise, right? And then we'll do the same thing for dog. And oh man, this is gonna be beautiful to show you guys how this stuff works. So we're gonna say get dog is hungry, and we'll say dog, my dog, and now we rename this variable. And then now we say check dog is hungry, and we're gonna pass in our dog. Andre, I'll get to your. I want to finish this topic, but I'll get to that. I want to finish this because it's going to be a little confusing until then. So we want to check if they're hungry, and then when they're done, we want to say time has passed, or something along those lines, right? Because what we want to do is we want to say, you know what, we can not break this out into another function. We can keep it simple for now. We can say lion dot hours to hungry timer minus equals 1. So subtract 1 from it. This is a C# way of saying minus 1. It is equivalent to saying this. It is equivalent to saying, oh, well, I guess we'd have to access it again. It is equivalent to saying this, right? We say our timer is equal to our current timer minus 1. That guy is a shorthand of saying that, so you don't have to type all that out. And then we also want to do the same thing for dog dot hours to hungry timer minus equals 1. And so this while loop is going to be ran as fast as the processor can go, right? So we want to wait for a second. So this is going to get a little more complicated. But we're going to say, I believe there's a thing called timer. C# timer. It's system.timers. System.timers.timer. Haha. And we didn't import system. Oh, yeah, we did. Never mind. Time. Huh. Apparently you have to include system. Okay, all right. Not going to question it. We'll come back to it at some point. Also, fun fact. If you have something on the left-hand side, and since we know the type of it, Visual Studio can automatically say, hey, it's on the left-hand side. Why don't we make a new thing of that? And then we can say timer dot start. And then we can say timer dot elapsed. So how long has it been, right? I think we want the. I saw a constructor for an interval. I wonder what that does. Because we basically want to be able to have a timer that tracks every second. Okay, so the interval is the time in milliseconds between events. So let's put 1,000 milliseconds because that's 1 second. Timer dot. Okay, this is going to be real complicated. We're gonna gloss over it and pretend it didn't happen. What do we want to call this function? We'll call it make them hungry. Make them hungry. No, I didn't copy it correctly. Upsetty spaghetti. Okay, this is getting too complicated. We're gonna avoid this. I feel like this is not covering the point that I'm trying to cover. If we hit start, watch what's gonna happen here. You see it saying roof, roar, and woof a lot, right? Because this is running super duper fast, right? And then at some point it's gonna say, hey, we like use too much memory, quit it. So the reason this happened is that this is running so fast that it's not using every 100 seconds. It's happening every 100 ticks of the operating system or of the program that's running. In this case, that could happen in like 3 milliseconds or even less, depending on how fast the program's running, right? Um, so timers are notoriously kind of a pain in the butt to deal with without doing a little bit of complicated stuff. If you do, we want to proceed down this route? Does this make sense what we're trying to do? I'm trying not to get it overly complicated right off the bat. Threading depth. Oh man, Tyler, that's a great idea. Why didn't I think of that? I know okay, I did think of that. I didn't want to explain it, but we'll do it. Where do you come from? Okay, so what this is going to do, thread dot sleep. So we have the concept of threads, which basically means I have a process running on one of my processors, or on one of my cores on my processor. We're going to say, hey, you, Mr. Thread, will you sleep for a little bit? And in this case, we're going to say, yeah, you sleep for a second. And it's done in milliseconds, so 1,000 milliseconds is a second. So if we run this, it should be 3 seconds before it prints anything out. I haven't used this, so I'm going to assume. Okay, 1, 2, 3. Woof. Haha. Woof. So now every second woof is going to be called because we're less than 0. And lion's not going to do it until 100 seconds have passed. We could change it to 10 just to prove that it would work, but we're not going to worry about that yet. Thanks for the recommendation, Tyler. That was way easier than what I was trying to go for. Yeah, Duncan, that's a really good point here. So you notice you see how I have these dots here. So normally, so console, for example, you see how it's okay. I'm trying to cover too many things here. You see how this guy is grayed out. The while true is going to go on forever, so we're never gonna hit this line, and the compiler says, "Hey, this is unreachable. So why do you have this here?" Okay, so the system.threading.thread.sleep. This is like a library in the .NET Framework system. And inside of system, we have threading, which allows us to do threading operations. And here we're going to do something on a thread, and on that thread, we're going to sleep. So what we could do instead is import system.threading. And now, since we have system.threading, we could use thread.sleep, wherever we want, without having to include system.threading. Whereas if I commented this out, it'd be like, dude, we don't know where thread's from. You didn't import it. Like we don't know where to look, right? But this is what's called a dependency, right? We depend upon system.threading to be loaded into our program before we start, so that we know what to do with this thread.sleep thing.
Just a quick question here. Does C# have anything like Java's .util.all?
I assume you can just do system.star.
Would it be? That's what I was thinking, but I wasn't sure.
Maybe not. It probably does, and I'm probably just haven't used it before, to be honest
No,
with
you're
you.
good. I was just kind of wondering real quick. I can always Google it.
Yeah, I'd Google that. I don't know off the top of my head, to be honest with you. But these are the type of fun things that I like to look up so that I do know them and for the future. And that's why these questions are great, because obviously I don't know everything. And I've only used what I thought was necessary at the time. And I'm sure there would have been better ways of solving things that I just wasn't aware of. And that's why it's great that we have this like feedback loop with people in the chat. I'm going to go back and read through some of the chat that I missed, because this should make somewhat sense. We will step through this line by line and show you what's happening when the questions are done. Okay, so Andre said, slightly off topic, is there a way to have the base class but have it not accessible? So I would be able to call a new lion and a new dog, but not new animal. I believe you can make the actual animal class. Okay, so what he's saying is you can do this, but you could also do this. Well, if we have a zoo, like, the concept of an animal doesn't make sense. We want to have a specific type of animal that we're creating. So he's asking is, how do we prevent this from happening? And I believe the way you can do that is by typing virtual into the class itself. No, I'm wrong. Is it sealed? No, sealed means it can't have a child. Is it abstract in C#? It is. Wait a minute. It still allows it. No, it doesn't. Okay, yeah, you were right. Good call, Duncan. So yeah, abstract basically means we're not concrete. We're abstract, right? We are something that exists, but you can't use us. You have to use one of our children, right? So you either have to use a dog or a lion to make an animal, right? So if I do, okay, this is probably not going to make a whole lot of sense. I can create an animal, and it's actually filled in with a lion, but we can't create an actual animal itself because that thing tangibly does not exist. Do, 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 do. Sorry, catching up on the rest of the chat. Okay, cool, we're good. Okay, I'm gonna pause for one more second and make sure nobody else has any more questions. I'm gonna check the Discord chat as well and make sure I didn't miss anything in there.
So abstract essentially in C# just acts as a filter for information.
So let's take for example a shape class, right? Like let's say I want to generate. The shape class has a function called area. I want to get the area of a shape, right? So subclasses of a shape would be a circle, a square, a star, and so on, right? Well, a
Right.
shape itself doesn't have area. That doesn't make any sense. I can't just create a shape that logically doesn't make sense. I can only have a square or a circle, like a instance of that type of object, right? So abstract prevents you from creating an instance of shape. You have to create an instance of one of its children. But what abstract allows you to do is still have those common things that those classes would have. So you don't want a shape to have to, like, for example, lion here. It doesn't have any variables. It only has the variables that comes from its parent, right? So, for example, if we're sticking with the shape thing, like a circle could have a radius, but a square wouldn't necessarily have a radius. So in circle it could have a radius, whereas in square it could have a width and a height, right? But still, they would both have in common the area function, right?
Right. I
So
think Tyler just kind of answered my question. All lions are animals, but not all animals are lions, essentially.
very good explanation. Yes.
Right.
So to drive this point home, you see how we have this check dog is hungry and check lion is hungry? Why don't we just check if an animal is hungry? Because all animals have whether or not they're hungry, right? Ooh, now we're getting funky. So now we can just pass in animal, my animal, and we can say my animal dot get hungry and make noise. And depending on what type of animal it is, it'll handle it for us. We don't have these anymore. We want to do check. We didn't rename the function. We want to do this, right? We want to pass in what type of animal it is, and it'll handle it for us. So if we go ahead and hit start, every second we subtract 1 from their timer. So after 3 seconds, the dog starts saying woof because we ask if it's hungry. Well, its timer is less than 0. It's been 3 seconds, so start making noise. Whereas it hasn't been 100 seconds for the lion, so he's not going roar. Duncan does have another good point. I did have to do this. I kind of glossed over it. You see how in the parent class, these are public? Well, if I made them, let's say I made this guy private, and I go back down to lion. Recompile. Oh no, all of a sudden it doesn't know what it is. It says hours to hungry is inaccessible due to its protection level or access modification level, whatever you want to call it. If it's private, it can only be accessed inside of this class, basically from this curly brace to this curly brace. If it's public, it can be accessed outside of this class. It can be accessed in its children. It could even be accessed lion dot. You can even access it in the zoo. But wait a minute. Let's think this through. The lion itself handles. Okay, hold on. Let's go undo this change. The lion itself handles whether or not it's hungry, right? Does that make sense? We shouldn't be able to access it from over here because let's say we're working on a team and someone says, "Oh, let me just subtract from the timer in here rather than having like a timer in the animal itself or something," right? What really should happen is these should be protected. And what protected means is they can be accessed in the animal and any of its subclasses, but it can't be. Okay, we have hungry to Okay, we can see is hungry and hours to hungry timer, but we can't see hours to hungry, right? Does that make sense? So basically we're saying you are protected from outside of me or my children. So using public, private, and protected allows you to figure out who should be able to access these things and why. You almost always want to make every property private and then have only their subclasses handle them, or have only your public functions handle them. That way a bunch of different places can't access your variable and you're like, why is my variable not set to the right value? Well, in the zoo you subtracted, one from the timer, but Billy Bob Joe over here in the I don't know, banker class also subtracted one for lion because he's dumb. But you wouldn't know those things without like, inspecting your code, and that would take valuable time away from you. Does that make sense?
Yes.
Perfect. Okay. We strayed so wildly from what I wanted to talk about that I almost want to commit to it and keep going, but I also want to stop and make sure that everybody understands the things that have gone on, and make sure I don't need to reiterate on anything.
Man, just go for it. Really, I'm just along for the ride.
And the nice part is we can keep doing these projects and small things like this until they make sense. So like if you're like I don't really understand what this thing is, well we can use it in another way in another small project.
Yeah, man, absolutely.
Okay, so let's do some cleanup, right? In a normal project, I wouldn't have these comments. Um, can we? I forget. Can we just make it without the parentheses and it still works? No, that's abstract only. Okay, so we don't want this to be virtual because we don't want animal to do it. So we can make the function itself abstract, and it doesn't have any implementation. So when you make an abstract method, all it needs to know is what it returns and what it takes in, right? So that way, lion can still tell it what to do, but animal doesn't actually have a make noise, right? Because an animal doesn't really know if it makes noise. But the parent of an animal can check whether or not it's hungry because we know if it's hungry or not, right? Let's look at some of the other concepts. Let's try and bring them in here. User input. We'll do that later. Conditionals. Aha! I got a great option for this. Okay, so right now we're just returning whether or not this is less than 0. What we could have done instead is we could have said if our hungry to hours timer is less than or equal to 0, return true. Otherwise, or else, return false. This one line is equivalent or synonymous to these 6, 7 lines, 8 lines. Yeah, I can count. Because basically what this is saying is return whether or not this is less than or equal to 0, right? This is a Boolean statement or a conditional statement. So this, if it's less than 0, to return false. Like this resolves to true or false, right? Whereas this checks if this is true, and if so, return true. Otherwise, return false. So this is like, as a beginner, I probably would have written this, but now look how simple and clean that is. I also, to make it more clear, I could have said bool is hungry is equal to this, and then return is hungry. Because that makes a little bit more sense. We say, is he hungry? If so, return whether or not he's hungry. But that does overlap with what we have up here. So what we could do instead is we could say, we don't want to declare a bool because we already have whether or not we're hungry. So we're going to say is hungry is equal to this, and then just return that variable that we set up here because we already have one, right? And now our is hungry is actually set, whereas before we were just returning it, right? And this variable will always remain false. So that would no, we want to redo. Yeah, there we go. Okay. So now this behaves as expected, where we get whether or not we're hungry, which sets. Well, okay, so this kind of doesn't make sense, right? When we're getting whether or not we're is hungry, really all it should do is return whether or not we're hungry, because this guy should be private, right? Because we don't want this guy to be able to. We want the animal to figure out whether he's hungry or not. We don't want somebody else to tell it whether he is or not. Does that make sense? Um, so then what we need to do is now the timer, the animal needs to keep track of how much time has gone on, not the zoo, right? The animal's body knows how long time has gone on, not the zoo, right? So we don't want this timer to be going on. We still want to be able to check if the animal's hungry, and then maybe I don't know, the when we check if the animal's hungry, if he is hungry, we can say, zookeeper.feed the animal, and then that would reset his timer, right? We could do that. So now we need to figure out how we want to um, over time decrease this timer on the animal itself. So what I'm thinking is this thing. Um, hmm. I'm thinking two things here. We could either have a method on here that is kind of it's on its own thread, right? We just say, hey, yo, Mr. Animal, you started. Go keep track of yourself. Or we could do kind of what we were doing over here, but we don't want to actually set his timer. We want to tell the lion second has passed, or something along those lines, right? We when we're not inside the animal class, we really want to avoid changing his stuff. We just want to be able to access his stuff, right? We really want to avoid changing his stuff because we don't want multiple different places to be changing where his stuff. Oh my god, I keep saying stuff. We don't want multiple different places changing the properties of our animal because we want as little points of failure as possible, if that makes sense. So we'll go ahead and we will create this seconds has passed method, and you'll see it's freaking out because we haven't created it yet. So the okay, quiz tab. Where should the second has passed method be implemented? Should it be implemented in the animal, the lion, the dog, or all of them? Go. Alex or Stefano, feel free to answer, or chat. I don't care. Or we can sit in silence. That works. I'll wait a second for the chat to sit. Elon and Basil, I would agree with you, but I want to hear Jonathan out. Why none? Why would none of them implement that? Because what I'm thinking here is we want. I'll tell you my personal belief before I ask you your thoughts. I guess I think the animal should do it because all animals will need to deplete their timer, right? We don't want to implement it in both lion and dog. That doesn't make sense. They're not doing anything differently, right? They're both subtracting 1 hour from their timer, or in this case 1 second, right? So if I were to do this myself, I would just say public void. Yep, I'm in Tedbird animal because time works all the same for all of them. Correct. Yes, that was my thought process.
Why wouldn't you just override second has passed in each one?
Because why would you do it twice if you're doing the same thing?
You know what?
Yeah, does that make sense? Like we didn't override get is hungry, right? Because we're just checking whether or not he's hungry.
Right.
Yeah. Do 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 do. Okay, so second has passed would literally just say, or I guess it would be hour has passed. But I don't want to copy. I want to Control R twice to type hour, and then notice how it will. Oh my goodness. Notice how it will even change when you rename. It'll even change in a different file, not just the same file. Elon, you would be right. If time did behave differently with different animals, then yes, we would have to do this in the child. But this kind of hits on a principle of computer science. It is it's Yagni. You aren't gonna need it. If if you only are going to use it once, until you find a case where it will be different, there's no reason to do that, because if you end up not needing it, you've done all this extra work for no reason, right? So let's do it the simplest way possible right off the bat. And then if we end up needing it, sure, we can implement it in the children. So all we're going to do, if an hour has passed, we subtract 1 from our timer. Yeah, makes sense. And when an hour has passed, let's go ahead and check hungry for ourselves, right? And I don't want to do that in here. I want to do another function to keep this very clean and broken out. And checking whether or not we're hungry is going to be private, right? Because nobody out here is going to check. I misnamed these functions a little bit. Let's go ahead and do private void check hungry. So after 1 hour has passed, now we want to check if we're hungry. So now we're going to do the. Remember beforehand we had return. Hours to hungry timer minus equals 0. Well, we're not going to return that anymore. We're going to set our is hungry to that. Are we hungry? Well, is our timer less than or equal to 0? Then yeah, we're hungry. Otherwise, false, right? So after an hour has passed, then we check if we're hungry. We this is only one line, right? We could have just put it right here. But to make this absolutely clear what in the world's going on, an hour has passed, then we check if we're hungry. How do we check if we're hungry? We check if the timer is less than or equal to 0. Jonathan says, animals don't really keep track of time, though. That's more of something that just happens, and the animal hunger depends on it having happened.
I mean, logically, if you think about it, just think of like you said in the beginning, just a zoo timer, just how often the zookeepers need to feed the animals to make it make sense.
Yeah. I guess I could see it going either way. In my mind, my reasoning for doing this was I want the animal itself to edit its hours to hungry timer. Oh, and okay, so now we need a function called feed animal. Sorry, this just popped into my head. Now we're gonna say hours to hungry timer is equal to hours to hungry, right? Because the timer is less than or equal to 0, right? It's been enough time that their timer is 0. Now we want to reset it, the timer, to how long it should take them to get hungry for the next time. Does that make sense? So the way this is going to work is every second we check if that animal is hungry. And we do that by saying, is he hungry? If so, he should be making noise. If he is hungry, let's say my animal dot feed animal, and maybe the animal shouldn't be feeding the animal. That doesn't 100% make sense. Maybe this should be a zookeeper dot feed animal. But we're gonna follow along in this example for a little bit just to make this stuff make sense. So we check if the animal's hungry. If he's hungry, have him make noise and then feed him. And then tell it that an hour has passed. We probably could break these 3 out for like time has passed into one function, but we'll avoid that for now. So let's go check if this works. I'm gonna lower the timer for lions down to 10 seconds because 100 seconds just feels like too long. So what I'm expecting here is after 3 seconds, the dog should say woof, and then he should be fed. So 1, 2, 3. Yep. 1, 2, 3. The dog should be fed again. 1, 2, 3. The dog should be fed again, and then the lion should be fed. Roar, and then it's gonna keep repeating the same process, right? Okay. I feel like I have some separate files here, and understanding the whole structure of how everything works might get a little hazy. Do I need to revisit any of this?
At this point with Stefano, I'm probably just gonna I got to about an hour and a half before I wrote down I needed to rewatch something, so
Okay.
I'm pretty okay.
We are at, oh my goodness, are we at 2 hours? Oh my god, we're at 2.5 hours. Okay, all right.
Yeah.
I know your guys' brains.
No, we're good. Yes, sorry.
I know you guys' brains may be getting a little tired at this point. We can call it, or if everybody's still interested, I can keep going. You guys can rewatch in the future.
Honestly, like my crashed like 10 minutes ago, but I'm just restarting it now. But I'm it. But if you guys want to go on as well, there's plenty of stuff for me to rewatch later.
Yeah, it looks like we still have people in the chat, so I'll keep going for them. If you guys need to hop out, feel free.
Okay.
Basil says, if we had a cheetah similar to the one Elon talked about that has a separate timer of its own, can we redefine the hours has passed method just inside the cheetah to behave in a different way? Let's do it. We will create a new class, and we'll call him cheetah. And for some reason, we'll say that I don't know, cheetahs are fast. Their time goes 2 times everybody else's. Let's go look at dog and see what. Oop, oop, oop. I hit escape, didn't I? Yeah, it saved. Cool. We're just gonna copy these guys because they're gonna be doing the same thing, and we can just rename what all's in there. Because I'm lazy. Okay, so his hours to hungry. We'll say it takes him 10 hours to get hungry, and hours to hungry timer is still 10. We need to be an animal, but we want to override. Oh no, it's not there. We can't override it. What do we do? Oh boy, we make this guy virtual. So now in cheetah, now we can see hour has passed. So we can either call what's in the base, or let's actually call what's in the base. It'll still subtract 1 second. Let's just subtract another second after that. So now cheetah should happen every 5 seconds, right, instead of every 10. And then everything else should still behave as expected. Because virtual means it can be overridden, but doesn't have to be. Oh, this guy says roar. He needs to be, I don't know, I'm a fast boy. I don't know. I feel like I messed something up here, because it should happen right about now. Okay, we'll just override how the method works overall. So we subtract 2, and then we call our parents check hungry, which should be, instead of private, we want it protected, so we can call it in our child. Now we rerun it. What am I doing? Oh my goodness, thank you. I was never going to catch that. I never made a cheetah. And we don't need this animal because we're not using it. We don't need this read line because we're not using it. Also, notice how we don't need that read line because we have this loop going on forever. That read line was just waiting for us to give user input. We also need to check if our cheetah is hungry now. Okay. One, two, 3, 4, 5. I'm doing something very dumb and very obvious. What is it? Okay, it looks like it's not ever hitting I'm a fast boy. So it's never hitting make noise, which means if we call get is hungry. Oh, haha. We never told the cheetah that an hour has passed. So the cheetah was just always sitting at 0. Okay, 1, 2, 3, 4, 5. Cheetah. Haha. Okay. Looks like it works. Yeah, that makes sense, guys? Everybody watching in the stream? This is why animals couldn't keep track of time. You're right. And the reason you're right for that is look how ugly this is getting. Every time we make a new one, we have to tell it the time has passed. So what we could either do is we could put these things in an array of animals and just we'll do an array together. We'll call it animal array, and we'll call it the zoo, and we'll create a new. Actually, I don't like arrays. I like lists better. And we have to import collections.generic to get list, because list. So a list is literally what it sounds like. It's just a list of things. So you can, with a list, you can add to a list, you can remove from a list, and you can loop through a list. Lists are not fixed. When you create a list, it's dynamic, right? So if I just keep adding things to it, the list will keep growing. Whereas with an array, you declare the size of it when you start. So if you wanted to add to an array, you would either have to create a new array and copy everything over to it, or just make the array big enough that it would never get filled. So once we create each of these things, what we could do is we could say zoo.add. We could add our lion to our zoo. We could add our. Why am I typing these out? I can copy paste. Okay, so now we have each of these things in the zoo. So now instead of this, we can just do for each animal in our zoo. Let's tell that animal that an hour has passed, and let's check if that animal is hungry. Boom. Now, whenever we make a new animal, all we have to do is add it to the zoo, instead of making sure we remember to do these things down here. Yeah, I'm kind of with Jonathan and Basil here that time should be some sort of global thing here. No simple solution is coming to mind. If somebody thinks of one, I've been streaming for like 2.5 hours. My brain is not working so hot right now. So if somebody has a solution in mind, we'll do that. Otherwise, this is the simplest solution that I could come up with. But yeah, I agree that time should work different here. But now that we changed this, let's make sure that everything still works. Yeah, Elon, you're right. List doesn't have a fixed length. Well, okay, so when you create anything, it has a fixed length, right? You say, I create this list. When I create it, maybe it has a length of 0. When I add to it, .NET says, okay, you added something to it. Let's go request more memory from the operating system, and now we have that memory at the end of the list. And I'm not sure exactly how lists work in C#. I'm assuming it's one of two options. Either when you request more memory, it says, you know what, we'll just request a bunch of extra, and you can fill it in as you need, and when you get full, we'll request a bunch more extra. Or it says, we requested this block of memory, and then you know what, we'll keep a pointer. Like, normally when you keep track of things, it's like a sequential block of memory, right? But maybe they're separate blocks of memory, and you say, I'll have a pointer to where the next element is in memory, and a pointer to the next one, and so on, like a linked list or something. I assume it's a block and it requests a new one each time because it's not a linked list. But I'm seeing roar, I'm seeing I'm a fast boy, and I'm seeing woofed. Let's add a little bit of debugging to this. Every second, let's say console dot writeLine. I want to add just like a number, like how long it's been. We'll just add an integer for current hours. And we'll start at 0. And we'll say plus plus because that'll add 1 after we use it. So if we run it, we'll wait for a second. 0, 1, 2, woof. 3, 4, fast boy. Cool. Looks like it's working. We could put these in like the same line, or we could format it better. I just wanted to have some little amount of debugging so it would make a little bit more sense, right? Jonathan, that is a good point. In the future, we'll get to dependency injection. But yeah, that is a long road ahead. We could keep time in a static class. So we could just say, hey, yo, what's the time? So we don't have to keep creating. We don't have to do thread.sleep. We could do thread.sleep in like a static class similar to how this guy is static, and then just ask that static class. Like it could be like called like a time manager or something. And you know what? We should probably do that so we can get a more concrete example of how static class is. Because the only example of how the only example of how static works right now that we have is the main class. So let's go ahead and make a new class, and we will call it the time manager. And the time manager is going to be hmm. So when we create the time manager, we want it to just kind of run off on its own. So we're gonna have to start up a new thread. Okay, I like this idea. I think it may be too complex, unless I'm completely missing something here. Also, my headspace is 100% in Unity, and this is a new. I mean, it's not terribly new, but like handling threads is different in here because I'm used to using in Unity they're called coroutines, which basically says, "Hey, yo, you go do your thing over there. When you're done, come back. But you're not gonna interrupt me because you're on your own thread, right? The CPU will get to you when it has time. I'm more important than you." Um, yeah, I'm gonna wait for chat to respond here and see what you guys how you guys want to handle this. It wasn't a specific question; it was a recommendation. Um, the way we're handling time right now doesn't isn't clean, right? We are telling the animal that an hour has passed, or the animal itself should check that a time has passed, and it shouldn't be done in the main class. Like somewhere else should be keeping track of the time that has gone on. So I guess a good concept that this shows is that while this code works, if somebody were to come in and read this, they'd be like, you know, why did they make this decision? I really want to I really want to fix this, but um, my ticket says I should be doing something else, and this isn't a part of my ticket. Like my ticket meaning like a piece of work that you would do, as a developer. Um, so thinking through these things is really important for when others are trying to use your code. Just have a method that sleeps for 1 second and increments it. Why didn't I think of that? All right. So in our time manager, we're gonna have a static variable called actually, yeah, we'll have a static void wait one. I don't know. We'll call it hour, but really it's a second. Anyway, what's gonna happen is it's gonna be we gotta use threading again. Really, what it's gonna do is this guy for us. And so now we can just say, "Hey, Mr. Time Manager." Oh, needs to be a public static. Hey, Mr. Time Manager, will you wait an hour for us? The other nice part about this is maybe we don't want to wait an hour. Maybe wait a second, or maybe we wait 100th of a second. All we'd have to do is go in here and change one variable rather than having to look through the code, right? We just have to go to the time manager to manage the time. This still doesn't solve our problem of this guy. This still doesn't feel clean. Okay. Part of this not feeling clean is the spacing a little bit. That still works, right? My concept of threading isn't awful. Yeah, cool. It still works. I feel like that didn't solve our issue at all. My head is struggling here. So what we could okay, this is fun. This is fun. We could get into the concept of delegates and events here. I believe that was further down in my list. Okay, so we did a little bit of loops. We had a four each in a while. We didn't really go over four. It's very similar. We have access to lists, so we created a list using just new list. We added items to our list. We didn't remove any. I'm not terribly. I mean, we could, if we want to be morbid again, we could say if the animal died, we could remove it from our list. But that's literally just saying, zoo dot remove, and then whatever the object is that we want to remove it. Or we could say what. I believe there's remove at. Yeah, remove. So you could pick which index to remove it at. Do the animals need to now go back to the time manager to see how much time has passed? That would probably be a good idea. Wouldn't you just need to define time that increments in time manager and add an if statement in the while loop that calls feed animals after X time has passed? The animals need to get the current time from the time manager and keep track of when they ate instead. Yeah, Jonathan's solution is the best there. So what we could do, the time manager would have not only this wait 1 hour, but it would have the current hour, I guess. Public static int current hour is equal to 0, and then every time we do this, we just increment this guy by 1, right? So now we have some way to manage the hour, right? Obviously, this isn't realistic. We'd have to keep track of a timestamp, which would include like a date, a month, a time, all that jazz. But we're just gonna keep track of number of hours to keep it simple. Or hours passed since starting up, basically. And so now what we could do is in the animals, yeah, Tyler, thanks for coming. I hope you learned something. We'll get more and more complex as time goes on. Okay, so when we wait an hour, we increase our timer. This also pauses right here for a second, right? Because it goes into this function. I hit start. My bad. It goes into this function, right? It doesn't actually break off into a thread. It says we're still on the thread that we're on. Let's tell this thread to wait for a second and then execute the next line. And then since this line is done, we can go back to where we called it and keep moving down, right? So now in our animal classes, they need to get the current time, right? Or track how long it's been since they last ate. So now they can say hours since feeding. So now I feel like if we didn't use asynchronous, meaning like or if we didn't break things off into their separate threads, we'd still have to like tell these guys to go check that the time has changed. I don't think this is solving our problem. So we'd basically be doing the same thing like this. And we don't tell it that an hour has passed, it just checks whether or not it's hungry. Yeah, that makes more sense. So we check if an animal is hungry, it will, in check animal is hungry, just calls whether or not it's hungry. So we don't actually do an hour has passed. When we check whether or not it's hungry, we check if the hours since we've been last fed is greater than or equal to the number of hours since we've been hungry. That makes more sense. So if it takes 3 hours for us to get hungry, and it's been 3 or more hours, then yes, indeed we're hungry, right? So how do we get the hours since feeding? We go to our time manager and we say, hey, Mr. Time Manager, how many hours have passed? And we need some way to, if the, hmm, we need some way to reference the last time that hours have passed. Uh, hmm. Can check time with the, yeah, when you check if they're hungry. But we need to increment or check, oh yeah, this guy needs to be hours since feeding. It's going to be 0 actually, because it's been 0 hours since we've been fed. We need some way to set the how many hours it's been since last feeding. So we could just set the naive way to do this would be to say, well, this guy said it's been a second since the last time he fed, but at the same time, why did I not like this again? It still works, right? Oop, what'd I break? Yeah, we don't need this guy anymore. This guy doesn't exist anymore. All we need, okay, that actually cleans things up because now we need to know how long until we get hungry. They each have make noise, and I'm going to finish. Growl, and now the cheetah needs to override this guy, right? Because it was overriding time has passed or whatever it was overriding. Protected virtual. Ah. I'm doing something wrong here. Cannot change access modify. Oh. There we go. So I was trying to use the autocomplete when this guy was public. I tried to type public override, then have it fill in check hungry. But since this guy, its parent is protected, it wouldn't autocomplete because it doesn't have the same method signature or access modification. Access modification meaning its level of protection. Okay, so then the cheetah, instead of doing this guy, it should add 2 hours since it was feeding, or we could just change its hours to being hungry, which would be the same thing. But we were trying to show how it would handle time differently, I believe was our goal. Also, we can just call base dot check hungry. If we wanted to add 2 to it, we'd add 1 here, and then we'd add 1 when we called check hungry. Okay, let's see if she still works. Doesn't look like it. Okay, so what we do, we wait, we write our current hours, and then for each one we check if he's hungry. When we check if he's hungry, we ask if he's hungry, and if so, he makes noise. The zoo shouldn't be telling the animal to make noise. The animal should make noise for itself. So then, after we check he's hungry, we should say if he's hungry, tell it to make noise. It should tell itself to make noise, right? And this is all green because we're running. So yeah, the zoo should be feeding the animal and checking if it's hungry. The animal itself should be the one making the noise, which makes more logical sense. I still don't think it's going to work. I feel like I'm missing something blatantly obvious. Yep, dog should only take 3 seconds. Okay, so let's, I'm sure I can figure out the problem just by looking at it, but I want to teach you guys how to debug. So what we're going to do, we're going to put one of these magical red breakpoints here. and we're gonna hit the start button. And what it's gonna do, I'm gonna put these guys next to each other. We're going to make some room here. Okay, so what we're gonna do. Basically, the way this works is our zoo, it stopped at this line, right? So what we want to do is we want to step through each of these lines and check what in the world is happening, right? So we could see, like, if we just hovered over things right now, we could see our current hours should be 0, right? Actually, we can delete that. Hold on, let me pause. We're not even using that anymore. Wait a minute. This guy shouldn't be writing that out. The time manager should be writing that out. So the time manager manages the time. That makes more sense. We could also, while we're on this cleaning spree, we don't need to declare this lion because we're only using it in here. So what we could do is just add these animals to the zoo itself rather than creating them, because we're not accessing them anywhere else, right? We're accessing them from the list through this for each loop. So now we just create the zoo, add the animals to the zoo, and then check if the animals are hungry. Man, that's way cleaner. And then when we check if the animal's hungry, we get if it's hungry and feed it. I'm liking this. This is getting better. We also don't need system.threading anymore because we're not handling time. We'll leave system in case we ended up writing console.write lines. Okay, so back to where we were. Let's go ahead and breakpoint on the for each, and we'll look at what each animal has. So when okay, we're at 0 right now. So if we look at the time minute, Alex, your cursor. if we look at the, I guess we didn't go into the time manager. Hold on, let me reset this so you can see how this works. Okay, so these little blue buttons up here, we have 3 of them: step into, step over, and step out. Step into says if you call a function, we're going to go into that function and see what's happening. So if we hit step into here, it should go into wait 1 hour. So if we hit step into, you'll see the arrow is pointing at this line. We're on the first line. We haven't executed anything yet. So if we hit step over, we're going to step over 1 line, right? So if we step over another line, you should see, oh, hey, the console.write line happened. Oh, hey, look, it just now did. And then we're going to wait for a second. So if we hit step over, we should wait for a second before we get to the next breakpoint. Oh, there we go. And then hours has passed is still 0. But when we hit step over, hours has passed is 1 because we added 1 to it with the plus plus. And now we could either hit step over to go back to where we were, or we could hit step out. So I'm just going to hit step over. And I'm not going to click on these buttons anymore. I'm going to use the hotkey that it tells me, F10. So I'm going to hit F10. And now we're going into the for each loop, and we can see in our zoo, what do we have? 3 animals, a lion, a dog, and a cheetah. And if we open up the zoo down here, we could either open up the zoo down here, or we could hover over it and hover over each one. But I think that gets a little annoying if you happen to miss and you have to reopen all of them. So we'll look down here. So a lion, it's been 0 hours since he's been fed. He's not hungry. 0 hours since he's been fed, and he's not hungry. So we're going to loop through each of the animals. So if I go in here, you can see our current animal is dog, and then we go back through it again. Our current animal is cheetah. And then we're going to go to the end, and we're going to go through the while loop again. Okay, so now, as I go through, if we go into the check animal is hungry, we go to into his get is hungry, he just returns if he's hungry. Ooh, we didn't call check hungry, right? Where are we calling check hungry? Nowhere. That's our problem, right? We're only calling... Ooh, wrong button. Whoopsies. F12 takes you to where the function is declared. So if I hit F12 on this guy, it'll take me right to where it is. So we want to check if he's hungry and then get if he's hungry. That doesn't make a whole lot of sense. We should just go ahead and make... I guess we don't really need 2 separate functions for this. We could, when we're at the end of this... Was this guy doing anything? No, it's just returning is hungry. We can just return is hungry down here, because we're setting it based off of how long it's been since he's been fed, right? And then since this guy is void, we need to return a bool. And then in Cheetah, it's probably broken because this guy was void as well, which needs to be a bool. And then we want to return whatever the base says after we've added one to how long it's been since he's been fed. Okay. What's broken now? We didn't change this guy. What'd I call it? Ah, this was the guy that was protected, so we need to make him public so that he can be called from outside the class. And if we save, let me check if he's hungry. Have a good one, Elon. Thanks for coming. Okay, so now if we will turn off this breakpoint. We can always turn it back on. Like if we hit continue and then the time is going and the program is executing, we can just hit a breakpoint at any time and stop it right there. And then if we uncheck the breakpoint and we hit continue, it'll just keep going on. 8, 9, and then at 10, we should roar. Yep. All right, looks like it's working again. Okay, we got it working. We cleaned it up a little bit. I feel like we're at a pretty decent state here that I'm somewhat happy with. If I were to do this like at work, I would definitely take some more time and clean this code up better before like pushing it up to GitHub and whatnot. For those of you that are interested in Git and whatnot, we are going to have a separate tutorial series for that because that isn't C# related. That's more language agnostic. So look forward to our computer science fundamental series that we go touch on all these individual points for becoming a developer in general, not geared towards a specific language. Yeah. Does anybody else have any other questions before I sign off? My brain is not working so hot right now.
Really well done, Fabian. Oh, I think I'm the only one here now.
That's okay. Basil, are you asking when the computer science fundamental series would be? If so, that hasn't been planned yet. I already stream on Wednesdays now and Thursdays for the normal one leaf stream. So that's gonna be down the road. I'm not sure when. I know it's really important. I know we need to get to it. I will just lose my sanity if I stream much more.
I do have one question. I could probably just ask you this in private, but just for everybody.
Sure.
Will you be streaming this every Wednesday?
And until I run out of stuff to teach in C#, I will probably end up migrating to Unity stuff because that's where I feel the most comfortable and have the most fun.
Right.
That's where I personally like to go, but I guess if people lead me down a different road, then I can help them do that.
Right.
But yeah, I feel like I'd recommend watching this video out into like hour-long chunks. Otherwise, you're probably gonna lose a lot of learning. Because I know my brain is struggling right now. I know if I was learning this stuff, not teaching it, my brain would be dead.
Hey, can you hear me?
Yeah, what's up?
Hey, I'm Jonathan from the chat.
How are you?
Yeah, I'm good. Nice series, man.
Thank you, man. Thanks for your help, by the way. My brain is not working. You got the issues that I would have chosen to fix.
Yeah, no problem. I mean, I'm not learning because I'm a professional, but it's good to just look at the basics every once in a while. And it's a pretty nice series.
Yeah, and I end up learning more about C# as a language itself every time I go back and do these type of things.
Oh yeah, C# is so rich with stuff, and they're adding even more now.
Every year it seems like there's new things that I just had no awareness of, like the thread.sleep. I come from Unity, so we use coroutines, so that was just a completely different thing for me.
Yeah, and the thing is, nobody uses thread.sleep anymore. Everybody just use the task parallel library.
Mhm.
But that's something that's even like way further in the future if you ever want to teach async.
Yeah, async will be a tough topic to cover. Do you have any questions while you're in here?
No, but I'd be interested in watching some Unity stuff if you're gonna be showing any.
It's not going to be for this stream specifically because it's C#, but I can pause this stream and start another stream and start showing Unity stuff. I have like a game that I'm almost done with that I'd love to show off.
Oh, cool. I mean, I didn't mean like right now. I
Oh,
mean,
okay,
like
yeah.
in general, if you're gonna have Unity streams, I'd tune in for those.
Yeah, I don't know. So my goal is kind of to go. Um, okay, so the way this came up in the One Leaf Discord, we do open source projects together, and people were interested in my game, and they're like, "I want to help, but I don't know how to program." And I was like, "You know what? I'll just make a C sharp series, so that way you can watch that, and if once you get through that, then we can move on to the Unity stuff." Um, so I don't know if I wanted to start the Unity stuff in parallel, or if I want to, do that as kind of like a succession to the series.
Okay, yeah, that makes sense. You probably need at least some basic programming for the Unity stuff, but then a lot of the Unity stuff is really just Unity stuff that you won't really learn elsewhere.
Yeah, yeah, a lot like console.writeline, thread.sleep, those things don't exist in Unity, for example.
Right, you wouldn't be using any of that.
Yep. I think what I really want to get across is the core concepts of like don't repeat yourself, you're only gonna need it once, or you aren't gonna need it. Like the core design principles on top of the language, because those will let you do Unity proficiently. You can Google the rest.
Yeah, that sounds pretty good.
Um,
Like a free copy of your game, please.
yeah, anybody that's interested, it's in like an alpha state right now. I'm waiting for Steam to give me approval to put my beta up. I need to make a new build. The build that's out there is a few levels are broken. But if you want a free copy, just message me.
Is it open source?
Yeah, it's on my GitHub. Ambid17 on GitHub.
All right, cool.
But yeah, we can sit around and chit chat in Discord. I think I'm just gonna end the stream because I feel like everybody's brains are probably dead. But yeah, so for people that are still left in the stream, in the description of the YouTube video is the link to the One Leaf Discord. I am much more active in that Discord than just about anywhere else. So if you ask your questions in there, I'll be able to help you better. But yeah, that's all I got for the C sharp for tonight. I feel like I went really off topic. We will revisit a lot of these things on next stream and make sure you guys have them locked down. But anyways, thanks everybody for coming. Thanks for watching. Thanks for participating and being interactive. I appreciate it.